Okay, everyone, welcome again. I'm too excited to connect with many friends and friends of friends. So it is not general public class, mostly among the known people and friends of friends. Because the training I do is a boutique training, not too commercial training. So it's out of my own interest in this field for quite a long time, where I've been doing research on big data and machine learning and artificial intelligence last 5 years, and sharing these discussions with many people around the world. So last 5 years with my own colleagues, and I trained them last 3 years in big data, and some of them are working already, like Harun, working in Cisco, and Vijay will be attending from Visa. And this is the field artificial intelligence I've been researching last 3 years, but last 1 year I'm pursuing hands-on. So this is what I want to share with you. So I've been interacting with the big data community and the artificial intelligence community. This guy is the creator of one of the software, the left side, which we use like Spark and Scala. I met him in the Hadoop world and we discussed a lot of things, what's going on there. I also teach to kids in the weekends whenever I get time to share some of the coding classes like Python and Scala. Sometime back, some of my friends thought Scala was difficult. So I just want to experiment on kids. In fact, I taught Scala for kids and they could able to learn very well. So why we should do this artificial intelligence? First of all, it is very high demand, highly paid jobs. It adds a lot of value for the companies. And it is not too complicated. What does it mean? Does it mean it's complicated? Yes, it is complicated, but it's not too complicated. We can learn. And it's very, very interesting. Lot of companies, lot of people going to Stanford, going to MIT, going to Carnegie Mellon, are working with associate professors, learning these skills. So it's not we alone. So I want to appreciate every one of you, first of all. Even CTOs are learning this. CMOs are learning. CEOs are learning. People like Jeff Bezos are talking about machine learning and artificial intelligence. Earlier, CEOs doesn't talk about these technologies and concepts. People like Jack Ma, multi-billionaires, are talking about this. People like Satya Nadella, Sundar Pichai, they are saying this is computer science 2.0. So it is too exciting. This field is so popular, not because this is just a technology and another skill. It is a discipline itself. It is a whole discipline. So you are entering into a discipline, not a skill. Because some people think, oh, at this age, I need to upgrade my skills. Do I really need the skill? It's going to be difficult. It's another skill. No, it's a once in 10 years or once in 20 years. So it is a totally discipline. You're entering into a computer science, actually. New computer science. Maybe our kids might be working in this area. They may not be doing exactly the same what we are doing. See, we used to use phones. They're using cell phones, smartphones. But again, they are phones. So we are entering into a discipline. It is a discipline. And I want to encourage this learning is your strength, not your weakness. Some people think, oh, I should go and learn, thinking it's a weakness. No, it's not weakness. Learning is your strength. Because nowadays earlier people used to talk about IQ, EQ, all those things. Now people are talking about the adaptability quotient, learning quotient. So I want to appreciate everyone, encourage everyone. I want to appreciate for attending this and exploring this. You may not be able to attend the classes, but that's okay. But this might put a foundation for you to explore in next 1 year. This is high demand. Everyone is doing in Stanford. Your colleagues may be people from Stanford. Tomorrow when you are in project, your colleagues may be from MIT and CMU, because it has no limit. The applications are too vast. It's going to touch every field. So and we are in the wedge of it. It's in the prime time. Now it is time to explore this. So I want to appreciate everyone. So let's connect with our friends, because people are very, very important. These skills will automatically come when we are discussing with an open mind, in an interesting way, in a fun way. So we don't want to get bored just listening this. So I've been doing trainings last 20 years, something or other. I've been teaching to kids, been teaching +2, been teaching to different professionals. I taught PeopleSoft, I taught Broad Vision, I taught big data. Now I'm going to share this. So, but throughout this, I learned how to make things interesting and easy. Because most of them, because that's how I learned. I was learning a lot of skills which I felt difficult. But some books and some videos or some people made it very easy. So it is not always the subject that is difficult. Many times it is with whom we are interacting, with what group we are interacting, how we are learning. So when it is interesting, you never feel it's difficult. So that's why let's connect with people, because people are very, very interesting to me. Everyone is unique and everyone background is different. Everyone can share. So that's why I don't interact as a student and lecturer mode. So we always say associates. So we have our learning associates. I have teaching associate also. I have a Harun who helped me to teach. And tomorrow you could be one who will associate with me to teach the people. So let me see. I think there are many people attending. Let me see. This is a new conference tool I'm using. I just want to see the participant, and we quickly greet each other. Just say name, from which city you are dialing in, and why you are attending this. That's enough, because what projects you are working, what skills you are working, how many years you are working, that's okay. That's not a very, very important right now. Right now, you want to know who you are, rather others. So let me start here. I see a DK, my college mate and a great friend, dialing from, he was in US and dialing from Hyderabad. I'm telling about him. Hey, DK, you want to greet others? How are you today?
Nice. Hello, everyone. Thanks, Rini. So I'm dialing in from Hyderabad. I moved back 8 years ago from US. I work for Hitachi Consulting, where I lead insights and analytics practice here. So I'm into data analytics and the stuff, mostly enterprise in SAP and Oracle. Kind of new and got motivated from Srini to enter into big data and AI world. So quickly, I think we have 24 people. I think I'll end there so others can add
Wonderful,
to.
DK. Welcome. We have Kiran. It's okay if you don't have video. We'll be stopping the video after some time because sometimes video is disturbing, especially the class is going on. Hi, Kiran, how are you? And you want to greet others?
Hi, Srini. Hi, everyone. Yeah, sure. I'm based out of New Jersey. I work in ERP products, mainly PeopleSoft. Been working in this field for 14 years now. And the way I started was I took a Srini's class in PeopleSoft. And now I'm looking to see what AI is about. I did take some big data classes as well. But at that point, I'm not sure if I want to do programming, so I'm still exploring what I'm going to do next. So that's about it for me for now.
Wonderful, Kiran. Welcome. So we have Sairam, my colleague, and lived in Fremont together, interacting on big data now. Sairam, welcome. You want to greet others?
Thank you, Srini. Good morning, everyone. This is Sairam Kavuri. I live in Charlotte, North Carolina, and I've been working on PeopleSoft for the past 20 years, and I thought this is the right time to switch over. And I did attend for the Srini's big data classes earlier, and this course is coming up with AI as well. So this seems to be very interesting, and I'm looking forward for this class.
Wonderful. Welcome, Sairam. I have Harun. We call him Nawab. So he was my colleague in Apple, and he associated with me on the big data batch. He did a second batch 3 years back. He is already working in big data, and interestingly, he's my teaching associate. He will be interacting with you on the big data aspects as I focus more on machine learning and artificial intelligence. Harun, how are you today? And you want to greet our friends? You're on mute. Harun, you are on mute. Yeah.
Hi, Srini. Hi, everybody. My name is Harun, and as Srini said, I have been associating with him for last 4 years. I was with him in his second batch. I moved from PeopleSoft to Big Data, and since then, for last 2.5 years, I'm working at Cisco on the Big Data, and I have been also associated with Srini for last 5 batches, helping and assisting him throughout the course. And I'm excited to learn new things and continue the journey with him and with all of you.
Wonderful, Harun. Welcome. So quickly, we have Basavaya from Satyam, I think rather Tech Mahindra.
Hi, I am Basavaya Vemuru calling from Hyderabad. I am with the Tech Mahindra from last 3.5 years. Earlier, I was with Satyam. I am into performance testing and automation testing. So only because of Srini's YouTube video, I got interest to move. I am planning to move my career from testing services into big data and AI. Thank you very much, Srini, for your help for enhancing our skill set. Definitely, I would be association with you.
Welcome, Basavaya. So you don't need to thank me right now. It's only beginning, our collaboration. We have great stuff to do ahead. Thank you. Welcome. So I have my ex-project manager, Suvir, with whom I worked, PeopleSoft. We did a great project. And last for 15 years, we are great friends. We share a lot of things, and we live more or less in the same place. Suvir, welcome. You want to greet our friends here?
Sure, Srini. So hello, everyone. This is Suvir Pawar. As Srini said, I and Srini, we go way back. I have also worked with Sairam on a project at Charles Schwab. So currently I'm working with Program Management Office at Kaiser Permanente. I've been in consulting. I've worked primarily with enterprise resource planning technologies, ERP technologies. But as Srini mentioned and some others mentioned, artificial intelligence and big data is touching everyone's life, no matter what domain or what technologies you work with. That is clearly the new frontier. So all IT professionals, I believe, will have to retool ourselves with some of these new emerging technologies. Looking forward to learning what AI and big data is all about. Thanks, Srini.
Wonderful, wonderful, Suvir. Welcome. So we have Razu, my best friend and classmate. We lived in REC, shared many years, and the last 25 years we've been interacting. Dialing from Hyderabad. He's friend to DK and knows Suvir also, as he visited us graciously at San Francisco. Welcome, Raza. You're on mute. You want to greet others? I can unmute you. Yeah.
Hi, this is Raju. I'm joining from Hyderabad. As Srini told that you know him for last 25, 28 years or so. I know DK too. So we are all from same college. So right now, my interest is like big data because everybody's interest is big data now. So I'm just exploring it. I'm just a beginner here.
Wonderful. Welcome, Raza.
Thank you.
We have Swapna. Swapna, welcome. You want to greet our friends? Swapna. Okay, we can talk to you. Next, we need to go a little bit quick. Narayana from Hyderabad. Narayana, you want to greet our friends? Let me go to Siva. Siva, my colleague in Apple. Siva, welcome. I'm unmuting you. You want to greet others?
Hi everyone, my name is Siva. So I'm ex-colleague of Srini and Arun. So I'm pretty excited whenever Srini teaches. So that drives me more interesting whenever he teaches new things. So I'm excited to explore new things.
Wonderful, Siva. Welcome. Siva and me worked in very good projects in Apple, and we presented common projects to the business. So we always had a lot of fun. So welcome back, Siva. We have Narayana, a friend, became recently a very good friend from Hyderabad. Narayana, you want to greet our friends?
Hi, Srini. Anybody hear me?
Yeah, everyone can hear you. Everyone can see you.
Fine. Hello, everyone. Good morning. Good afternoon. I'm very interested to learn big data, and I want to explore more about big data. So I'm learning more and more.
Okay, excellent. Let's go quickly. Shyam, welcome. How are you today? You want to greet our friends?
Hey, Srini, good morning. Can you hear me?
Yeah, we can hear you. Warm voice.
Hi, guys. I'm Shyam. Good to see you back all. I've been working with Srini for past 2008, since 2008 now. I mean, a lot of collaborations I did with him, and I'm excited for this new
We lost you, Shyam. You are mute.
Hello?
Yeah, we can hear you now.
Oh, yeah. So I was saying I've been collaborating with Srini since 2008. And I mean, I'm here actually to explore machine learning and collaborate with all the team members here and see how it goes. And I'm excited.
Wonderful. Welcome, Shyam.
Thanks for the invitation.
Okay, well, wonderful. We have Venki. Venki, how are you today?
Yeah, I'm doing good. How are you?
Yeah, pretty good. You want to greet our friends?
Yeah, hi everyone. This is Venki. I'm dialing from Michigan. I recently completed my master's and I'm new to this world and trying to explore AI and big data. Well, excited to learn more things. As of now, this is my background, and looking forward to learn more things about AI as well as Hadoop data.
Excellent, Venki. Welcome. Channa. Channa
Thank
is
you
our
for the
friend.
opportunity.
Wonderful. Channa is our friend, colleague in Apple. He associated with us on big data training and now working at Capital One. He's doing great. He always informed to his friends to collaborate with me, and we interact with on Facebook. Welcome, Channa. You want to greet our friends here?
Yeah, sure, Srini. Thanks for inviting me in the call. And with me, my kid, 4 years old.
Channa,
And
you're breaking. Yeah.
Are you able to hear Srini?
Yeah, we can hear you. Quick.
Oh, yeah. Thanks, Srini. So, hi, this is Channa. I'm working as a now senior architect in big data. So, because I was in a Java background, 10 years experience I have. So 2015, after introduced me Srini, and I joined as a big data. So from there I grew developer, and now I'm an architect position in the big data. I'm good to hear. That's why my kid also joined today with AI. He's having 4 years old. He wants to listen that. What is that AI? Artificial intelligence.
Wonderful, man. That's great. One of my other associate, she used to bring her kid 2 years when there was no babysitter. She used to bring her son to my class when I was teaching PeopleSoft. So that guy, you'll be surprised. Now he is in 9th grade or 10th grade. And both of us teaching kids on Python programming. He lives in San Jose. So exciting, so interesting to see the kids. Kids quickly grow. And even my friends DK came with his son to my home in San Jose. Now he is going to Carnegie Mellon, one of the top institute in the world, best university in the world for comparison. Congratulations, DK, for your son, and we really looking forward to even interact with him in future. Next, I go to Raja. Raja, can you quickly greet our friends?
Yeah, good morning, Srini, and hello everyone. This is Raja. I'm dialing in from Hartford, Connecticut, and I'm a recent graduate, and I'm trying to improve my skill set in big data and AI. Thank
Wonderful.
you.
Welcome, Raja. We have Shiva, my colleague here in University of Arizona. He's in data analytics. Shiva Chidra, you want to greet our friends?
Yes, yes, Srini. Hi everyone. My name is Shiva Chidara. I'm dialing from Tucson, Arizona. For the last 10 years, I've been working as a data warehouse, and database analyst at the University of Arizona here. And I've been attending all these sessions, that Srini is getting into. so excited and looking forward to this session also. Thanks, Srini, for the invite.
Welcome, Shiva. In fact, Shiva and we conducted a couple of workshops, big data workshops here in University of Arizona. And recently, we conducted a large-scale machine learning workshop for Hack, Arizona, where a lot of about 40 to 50 people attended. It's very exciting. We have Mohan Sure, our friend from Sweden. He used to attend big data classes from Sweden. Thanks to H1B, he came to US, and he is now working with Federal Reserve Bank, I believe, on big data. Welcome, Sir Mohan. You want to greet our friends quickly?
Yeah, Srini. Hi, everyone. Srini, first of all, thank you for inviting me as a AI classes. And guys, I'm working as a Hadoop developer from past 1.5 years. Right now, I'm working in the Federal Reserve Bank as a senior Hadoop developer. I'm collaborating with Srini from past 3 years. So I'm so excited to learn more about AI.
Wonderful, Mohan. Welcome. Channa referred Mohan, the relatives. It's great. He was so diligently attended from Sweden, and thankful to God he could able to come to US without, though he faced a lot of H1B issues. I think good things happen to good people, and that's good. Welcome.
Yeah, thank you, Srini. Because of you only, I got like a great opportunities in US because of your classes. I'm seriously heartful. I'm saying.
No, let's say we all work together, Channa and our whole team. You know how we collaborate. Let's move forward. That's good. We'll talk. We have Rinku. Rinku, how are you today? And you want to greet our friends quickly?
Yeah, hi. Good morning. Hello, everyone.
Yeah.
I'm right now from Detroit, Michigan. I work as a Hadoop developer over here, and I'm looking forward for the machine learning and all this kind of skills which is going in our company too. So looking forward to learn from you.
Wonderful, Rinku. Welcome. I'm pretty sure you will be having good insight today's discussion. Now we have Giovanna, my colleague in Apple. We work together on very good projects with Shiva and others. She associated with me on big data. She also collaborated with some other companies to acquire additional skills, and she's working in data analytics, I believe, in San Francisco. Giovanna, how are you? And do you want to greet our friends?
Hi, Srini. Hi, everyone. My name is Giovanna. I'm calling from Sunnyvale, and I'm currently working at Persistent Systems. Yes, I participated in one of Srini's big data classes, which was tremendously helpful. I went deeper into a program for big data, and now Persistent is trying to go strong in big data machine learning. So I'm trying to get more knowledge and experience and keep growing.
Wonderful. Welcome, Giovanna. I'm so excited to interact with you and other friends. Kiran Kumar. Kiran Kumar, how are you? And you want to greet our friends?
Hi, Srini. This is Kiran. Hello, everyone. I live in Tucson and I work at the University of Arizona in University Analytics Department. Since I'm in data warehousing, I want to explore artificial intelligence, big data. Since actually I feel this is the future, I'm looking forward to learn new things. Thanks,
Wonderful,
Srini.
Kiran. Welcome. Kiran is also pursuing masters in MIS, and we constantly discuss ideas on blockchain. He is also invested in Bitcoin. I hope everything is going good, Kiran. Okay. I want to welcome Sai Harshita. Sai Harshita, I think she is studying in ASU, Arizona State University, referred by friend. How are you, Harshita? You want to greet our friends here?
Hi everyone, this is Hashita. So yeah, I'm doing masters in ASU. I want to learn about artificial intelligence, machine learning and all. I have some coursework regarding that. So I want to explore more in that aspect.
Wonderful. Welcome. Let's move forward quickly. Ganesh. Ganesh is a friend of another friend. Surya attended with us on big data. I wish he continue fully. He's in PeopleSoft, I believe, has a good job, but it's great. A lot of things going on. Welcome, Ganesh. You want to greet our friends? Ganesh, you might be on mute. Okay, let me meanwhile go to Hema. Hema was our colleague in Apple, and she moved out of Apple to a good place, I believe, near Harun's place in Virginia. Hope everything going good with you, Hema. You want to greet our friends?
Hi, Srini. Hi, all. This is Hema. I am a Java architect working with Avian Incorporation. And I have an opportunity to work with Srini and Harun at Apple for quite some time. And AI and machine learning being the buzzwords in industry, I want to explore more on this side. So I joined this meeting. Thank you, Srini. Thank you for inviting me.
Excellent. Welcome, Hema. Good seeing you here. Swapna, we missed you. We couldn't talk to you. You want to greet our friends? Okay, Parvati from Hyderabad, I believe. You want to greet our friends? That's okay. If we miss, we'll catch up with the people. That's good. Anyone, you have just 30 seconds. You want to greet our friends before we get into topic? Okay, excellent. Okay, give me 1 second, guys. Okay, let me get into this. Let me share you the stuff. Okay, welcome again, everyone. I'm too excited again to interact with you. As I mentioned again, I want to congratulate to explore this. Please see this not as another tool. Please see this as a totally discipline. Everyone is saying it's computer science 2.0. So it's only a beginning. There is no end for this. There is no end for this. It is like evolution. Well, the time has come for this. So why it's so popular? Why is it getting so popular? Please see, companies, the course session name is Enterprise AI. There are a lot of research going on in the industry and the universities, the scientific communities, in the governments, in the non-government organizations. There's a lot of work going on in these areas. But why enterprises, especially the Fortune 500, 1,000, 2,000 companies, are so much interested in this? Of course, businesses are to provide services and products. In the process, they want to make money and they create jobs. They're very much important for the ecosystem. So they want to increase their growth. So they need customers for their services and products. They want to reach the people effectively. So nowadays, there is so many billions of people connected to their cell phones and connected to the internet and sharing their interests, sharing themselves. So companies knows today, if I go to if you go and search your name in Google or Facebook or somewhere in the cyberspace, you will be found. You will be found for your friends. You will be found for governments. You will be found for match agencies. You will be found for companies looking by your background. You'll be found for even criminals. So information is some way is very much open. So these people are connected to the internet. That's one side. Billions of cell phone, of course, billions of people. And another phenomenon that is really sweeping is connected car. Everyone loves cars. Everyone wants car. Everyone has many cars. Everyone wants many cars. So already cars are getting connected to internet, like your cell phone. Cars communicate at what speed they are going, how much brakes they are putting. Already a lot of cars getting connected. There's a forecast in 2025, all cars will be connected, all new cars, I mean, not old cars, all new cars will be 100% connected. Even some of them by 2035 will have autonomous. Autonomous has different levels of autonomy, level 4, level 5. Level 5 is fully autonomous. So governments are approving and companies are working. All car companies are working. In fact, one of our friends already working, his name is Akil, he's already working in Detroit on a connected car project, autonomous car projects, but applying a lot of data related, a lot of big data related stuff. So let's quickly see, when we talk about data, there's so much data. In 1 minute on the internet, this is what is happening. 87,000 hours of video is streamed on Netflix. And of course in YouTube also. 4 million searches going in Google. Please see, you may choose whatever you like, the rectangle. 20,000 posts on Tumblr, and 10,000 comments are made in Facebook. In just 1 minute, as we are talking, this many things have happened. So much going on. All these people for companies are customers. If not current customers, future customers. The companies want to reach them. When they reach people, they want to reach with the personalization. How they want to reach? When they reach you, you like them reaching you with a relevant messages. If they send nonsense, you will say that these people are sending spam. Go and check your emails. Nowadays, you might not be deleting emails. You get so many emails from companies with which you subscribed. They know even they might greet you on your birthday. They might send you coupons. They want to build a relation with you. They want to build a good experience about their products and services. They want to influence your buying behavior. The companies know your worth. Whether you are trying for a job, whether you have job, your net worth is 1 million or 100K or 2 million, or your lifetime value next to 10 years, your worth is 5 million or 10 million, whatever it is, they know. So the more they know about you, the more they can customize your experience. Of course, nothing fraud. The government is there to take care of the fraud things, but a lot of companies are genuine. They don't want to interfere unnecessarily. They want to create a good experience to the people. So we call these companies how they can reach you. So they are using multiple techniques. They collect the data, they store the data, and they process this data. That is one level. If they just collect and process the data, that's only a first step. They do use some techniques called Internet of Things and Big Data. So Internet of Things is whatever your tools, even your cell phone connected to Internet is the Internet of Things. Even though you think you are connected to Internet, in fact, your cell phone that is connected to. Your app will inform you. Interestingly, I was starting my car. As I'm driving, the cell phone knows you are accelerating. Your cell phone has an accelerator, acceleratometer or something like that. It knows you are driving. So it will start immediately without you asking, tells you it takes another 30 minutes to go to your home. You can go from this side. It will tell you. Sometimes it will be spooky, but people get used to. So companies, enterprises want to reach people. They can reach people more effectively, can create a good experience if they process the information, if they gain more information, more insight about you. So for that, they're using some techniques, machine learning techniques, deep learning techniques, natural language processing techniques to get a more insight, more cognition, more insight, more knowledge, more and more knowledge, more wisdom, tomorrow more and more. So it's all getting more insight, more insight, more insight. Because there is always a room to know about you, about us, about customers. Let's not take anything personal. Let's take, as a customer. Even we are all working for companies. We're working in customer systems and different systems. We want to know about our business users. We want to know about customers. The whole idea is to serve them. So enterprises uses these techniques. So this is what is called artificial intelligence, because you're getting more insight, more cognition. The more you know about them, you know more intelligence. Rather, your company has more intelligence about the customer. So intelligent does mean knowledge about some field or some person with a purpose to serve them. In the process, make money. To provide good product, to serve their needs. That is all about economics. That is all about business. That is all about enterprises. Even some companies providing a non-profit organization, still they will have customers. Take Kaiser, it's a multi-billion-dollar company, healthcare. They serve customers, they charge people, but they don't distribute the profits. They reinvest. Even government collect taxes and keep budgets, allocate budgets with an assumption it should meet the right needs. But of course, in the process, there'll be bribery, etc. That's all different matter. But if we have a right systems, even those things can be found out. So all these either the organization, businesses, different companies, different governments, they leverage the data, they gain more insight and can do action to meet their purposes. That is all about the enterprise artificial intelligence. So it encapsulates into these 4 areas. So if someone says enterprise artificial intelligence, this is the one slide you need to have in your mind. First, as a buckets, they have to handle the data, they have to apply these techniques. Right now, these are the techniques they have. Machine learning techniques, deep learning techniques, natural language processing techniques. So our agenda today is, you'll quickly understand how you store and just process it. We'll be spending an hour to understand a high level understanding. We won't go too deep because these are sometimes even 1 semester courses, even in Stanford, MITs. But especially today's class, don't dig too much, just get it. But I'm going to give you a very fairly great idea. I'm very confident in 2 hours, you never might have got this much insight about these areas. Because they're very, very interesting ideas. Very, very interesting ideas that the scientific community, mathematicians, computer scientists developed last 60 years. They've been developed last 60 years. They are not new actually. Please, I want to make you understand, these are not new techniques. But they became popular. These techniques need huge data, which is available now. These techniques need huge computing power, which is available now. These techniques need a lot of abstractions of the softwares, going high level, not going too low level writing code, not writing the code. Going to cloud and building hundreds of clusters of machines and running your algorithms, your software on terabytes of data. That is what needed quickly. All these techniques to implement, it takes hundreds of millions of dollars for the companies. It used to take hundreds of millions of dollars for these companies. But now, thanks to open source, thanks to cloud, thanks to a lot of higher level abstractions, now people can do this in millions. So nowadays, so that's where a lot of CTOs, CEOs, even people from Stanford, MIT, they are exploring enterprise AI. Not just for job. Some of them exploring to start a company. Some of them exploring their companies, the skill to turn their company into a new direction. Today, the music industry, Pandora, Spotify, Apple Music. Apple Music is so big, but a small company like Spotify could able to compete with Apple iTunes Music. They're giving a tough competition because that company CEOs applied these techniques. They built teams and they applied these techniques to reach the customers. That is where they got the competitive edge. They want to get a competitive edge and they want to compete very well. They want to progress. So this is what exactly enterprise AI. I'll be giving this in next 1.5 hours to 2 hours. Then we'll have a break after 1.5 hours. Then I'll show you one use case, anomaly detection. I'll give you a high level view of this, but you get a sense of it, so that then we'll discuss how the sessions will be in the next coming weeks, 10 weeks. Any questions at this time? Harun, DK, Razu, Ganesh, any questions?
No, Srini, I good.
Okay, very good. Let's go quickly. Harun, you get ready for 5 minutes. Quick demo on the how the data flows. First, I'll show them quickly something in this area, big data, how companies collect the data, how it process. But I want you also to share on your how you take data from the Kafka, how you push it into Cassandra, how you use Spark, certain tools. Just they get a sense of it. Just get ready in another 5 minutes. I'll give you a chance.
But Srini, I have one question. This is Mohan.
Yeah, Mohan, please.
Yeah, you said we are going to work with a huge amount of data. So what you mean by huge amount of data? 1 gigabyte is also a huge amount for my company, for example. So will it acceptable to work with IoT and AI tools for 1 gigabyte or 10 gigabyte, for example?
That's a good question. See, for now it is 1 gigabyte, but it might grow. But what happens is here, when you talk this machine learning, you'll understand. Machine learning means machine has to learn from the data, okay? So machine is going to learn from the data. If the data is sufficient to learn, maybe 1 gig is sufficient. But sometimes 1 gig data may not give more insight for that machine. So it is something like this, you see. You say in politics, you need experience. The Chiranjeevi and Pawan Kalyan don't have experience. Whereas YSR and CBN and Narendra Modi, they have experience, you say. So what do you mean by experience? So don't you think more data? They're exposed to more data points, more crises, more situations, more the data. It's not 1 gig. They might have exposed to 10 gigs of data. Whereas Pawan Kalyan and Chiranjeevi might have exposed to only 1 gig data. Do you get me? So depending on the situation. So sometimes for a bank, maybe since they are doing, yours is a federal bank, they are dealing with B2B, they don't deal with customers.
Yes.
You may not have a lot of data, but still that 1 gig data itself gives you a lot of insight for what you call, for the machines to take decisions. Then your 1 gig itself is sufficient for that learning. Do you get me?
Yeah. But is there any requirement, like you have to minimum 1 gig or 1 terabyte or?
No, it never put like that. It is the optimum, what is needed. Now, suppose say, some people say, one guy attended one orientation, say, you want to learn everything in big data before going to job. I said, if you want to learn everything, it takes 2 years. Can you wait for 2 years to get into job? No, you want to get into 6 months. So what is the optimum that is needed to get into job at that time, right?
Yeah.
So there is nothing like, hey, you need 500 MB, 1 gig, etc. It is for taking decisions, what is the optimum data that is needed? So it depends upon the situations. So in your Federal Reserve Bank, their idea is to increase the effectiveness of the banks because they don't want to have a crisis again in the US. So what all these banks, what are their reserve levels? What are the other things they are doing? Are they hiding anything, etc.? All these things, they might, your company might get insight with 1 gig data itself. So if you run some a machine learning algorithm with the data they learned, when the new data came, with what you learned, you can your programs can decide whether they are in compliance or not. If they decide, this is not compliant, they may not say reject them, but they can start a dialogue with them. So because a lot of decisions are not yes or no immediately. Even you see, suppose you are running a credit card, sometimes your credit card is blocked by your bank, thinking that it's a fraud transaction. But if you call them, oh, we blocked it as it felt suspicious. Oh, it is you used, okay, we are opening it. Are you getting me? So,
yes.
So your decisions are not going to, it's not a permanent decisions. They say, oh, okay, we blocked your card and we are going to block it permanently. They won't say. Do you get me? So your bank believes that 1 gig is sufficient, and your machines do take certain decisions and then interact with those banks. So let's move forward, Mohan. We will further. Okay.
Yeah, thank you.
That's a good question. Okay. So let me, Harun, please give me 5 minutes quickly. So here, this is the one of the architecture companies use to store and process the data. A lot of my friends who attended with me knows this, but I want to quickly walk you through. Here you see, companies collect the data using certain softwares called Kafka, or they collect data from Twitter. They can use some Amazon web services related softwares called Kinesis. These software called data ingestion softwares. These data ingestion softwares can inject the data into the system. As the data is flowing, I'll go here later. As the data is flowing here, suppose you are not storing immediately. You want to process the real-time data. Some data your company felt is a real-time data. They want to get the Twitter data and understand what customers are talking, good or bad. What television are talking, discussions about Narendra Modi or about some system or some budget. They want to get that information and process it in real time and get insights. So this is called stream processing systems. Stream processing systems. And you process this data, and finally you may store it in some softwares, Cassandra, or Elasticsearch, or MongoDB. So please see here, this is data ingestion, whereas this is data processing. I'm calling it as a stream processing because stream processing means it is processing as the data is flowing. So enterprises also say this is a speed layer because data is flowing very fast here. So you process it. So you'll be learning in the class how to run some programs called Spark and Scala, which you'll be learning in the class, to process this data and store into some other softwares called highly available softwares called Cassandra or Elasticsearch with connections, something like a data integration. So this is a data ingestion, this is a data processing, this is data integration. When you store here, this will be available for other needs. The available data, you can run machine learning, you can run deep learning, you can build web services, etc. Same thing can you also see here. Here, your company may not be interested to process it in real time, just like this. Your company may be interested to store first. First, let us store the data, because every data may not be important to process in real time. Some data can be processed in 1 day or 2 days, 3 days, 4 days time to get more insights about it, more customers. Suppose you may be planning, your company may be planning to send a promotions in 6 months. Then your company is launching a new product. Your company is launching a new product in 6 months. Your company wants to send a promotions for the customers. So you will be collecting the data, customer data, you will be storing here, either Amazon Simple Storage, S3, or you may be storing in Hadoop, or you may be storing in Hive. These are the softwares for data storage. You'll be learning in the classes how you store the data. Nowadays, companies are using S3 lot. There are some companies are using big data projects without Hadoop. So please don't get surprised. Some people think big data means only Hadoop. Yeah, Hadoop is very much used, more than 50% of projects. But 25% to 30% of companies run big data projects without Hadoop. So it may be surprising for you. So look here. So they may store this customer's data here, but they want to process these customers. They want to make into group 1, group 2, group 3. The high value customers, medium value customers, low value customers. Means certain range, some people who are buying lot. So they want to group them. How they group? They want to apply some programming techniques, Scala and Spark. Run some data processing and create groups and store those groups into Cassandra or Elasticsearch here. After storing these groups, run some additional algorithms to intelligently send the coupons or business deals. So companies call this as a speed layer. Companies call this as a batch layer. Batch layer because they store and process as a batch jobs. So this is a batch layer. This is a speed layer. Since the whole data comes here, from here, this is stored here ultimately to serve the needs, either web services needs or some additional machine learning needs or deep learning needs, run some natural language processing related stuff, get more insights, or connect from here to further data analytics team like Shiva and Kiran doing. So this is serving layer. So this is called Lambda architecture. This is how the pipelines are built. So let me quickly show you how you pull from Twitter, how you process a file. Then I'll give to Harun so that he will show you one particular example. Here I'm using a cloud platform, Databricks. In our class, you will be using this cloud. They give you free access for education and research. So the Databricks is a company which created Apache Spark, which is a powerful software that is popular in the big data world, which runs on Hadoop, which runs on S3, which runs on many other databases like Cassandra, Mongo, many other databases. It also does stream processing. So they give you a way to store the data. They give you a way to run the programs. I want to quickly show you an example. I'll take a Twitter example. So these programs can be, let me run this. It takes to relaunch and a cluster. It will give you the cluster, free cluster. It's very interesting. This is a cloud. So I'm just running here. See, basically, you import some libraries.
Srini, we are able to see only your presentation.
Oh, that's good. You told me. I'm glad. I think I need to share. Oh, this. Give me 1 second. Let me share you this. Thanks for share my desktop. Let me share my screen. Give me 1 second. I'm looking for an option to share the whole desktop, but I think it is sharing the application. Thanks, Arun, for informing me that. Okay, let me go back here. See, this is the Databricks cloud, where they give you free access. You can store the data. You can run some programs. Your programs you can write in the browser itself. In our class, you'll be learning how to write into editors like Eclipse and writing programs in the Unix shell itself. So multiple techniques you'll be learning, but don't worry about it. So in general, programming of the Scala and Spark, for the big data, you'll be using a lot of Scala, big data and machine learning, Scala and Spark. For deep learning and natural language processing, you'll be learning Python and PySpark. They look similar, Scala and Python. Wonderful languages. They look like English. Anybody can read and understand. But when they're writing, they get some difficulties. But with the practice, you can overcome those difficulties. So a typical way is you'll be importing certain libraries. Don't worry about it, how they, what details for today's class. So you'll be importing the certain libraries. So these libraries are libraries that connect to Twitter, the libraries related to Spark streaming, some Spark streaming and authorization libraries. You will be always needing certain libraries, just like your import or some libraries in the C or some Java. With the simple commands, they are connecting to the Twitter using some security keys. When you want to get some data from Twitter, you need to have credentials, not just user ID password, much security, authorization keys, consumer keys, secret keys, tokens, double authentications. Then you will connect to the Twitter using a context, streaming context. You'll be learning in the class. You'll use some Twitter utilities to create a stream and pull that stream using tweets. You pull the stream of hashtags, all the hashtags. You know, if you go to Twitter or Facebook, people put the hashtags. And we are going to print those. You're starting the process and await termination so that you can terminate the program. Just a few lines of import, and this is this one. Real code is this one. This is also streaming context. This is utilities you are initiating. Actually, it's a one line of code. With that, you may be able to pull the data from Twitter, the streaming. It is connecting. Let it connect. It connected to the Twitter now. This is now at this time, in the real time, the data is being pulled here. Please see here. Now this data, next 5 seconds, some other data. Next 5 seconds, come on. Some other data. Harun, do you see this? DK,
Yes, yeah.
Do you see this data, DK? It's pulling from Twitter, real time, all the hashtags.
Okay.
So this is the hashtags. So the companies like Apple, companies like Toyota, when they launch a product or when there is a Super Bowl ads, how people are reacting, they can pull the even specific tweets like, you know, hash Apple, hash Toyota, or relevant keywords people use. So, or they can pull all the Twitter data and can then filter their company's data in the real time. They can do that and store into Cassandra and other softwares where they can able to run the machine learning algorithms. I'll talk about this everything, but just to show you how you pull the data. Yeah, as I told you, the companies need to pull the data. Okay, I'm going to share to our friend Harun. He will show you how weblogs can be streamed and put into another software called Cassandra. Just to get a sense of it, don't worry about that we are going fast and making you overwhelmed. This is not how we do the class. This is just to get a sense of it. Okay, give me a minute. Let me give control to manage participants. Arun, where you are? Let me.
Okay.
Arun, I'm giving you host. I don't know how to give it control. So yeah.
No.
No, don't go to any theoretical explanation. Just show
No,
the.
no, no. I'm just showing the
Yeah.
use case, that's all.
Because we have a lot of stuff. That's why.
Yeah. So you able to see my screen?
Yeah, yeah.
Okay. So the use case, what we am trying to show is the log aggregation where the Apache logs, where you get the continuous logs that are generated web logs. So we do the log aggregation and put in a messaging tool called Apache Kafka that we also will be learning in the classes. And then we process that logs through the Apache Spark processing engine. And then we store either into the data Cassandra, that is a use case database, or into the Elasticsearch, which is again a data store which is used for dynamic searching of the content. So just to have you an understanding of the use case. And so based on these, I will be doing the executing just the use case, not going into details. So here we have the Apache log.
Logs are very important in companies, customers clicking your company's website and or any activity that is going on in your company, the enterprise is able to capture them as logs. So those logs he is pushing into a data ingestion software and processing it and storing it into another software. He just, to get a sense of it, he is showing. Yeah.
Yeah. So this is the structure of the Apache log, how each line is a message, is a log, and then each line has the information. So we'll be splitting the line into columns and get the data out and put it into the database tables. So split the this message into multiple columns and then store it into the database. So this is the log. So first we'll have to start our tools, the servers, that is our Apache, Cassandra, and the Kafka. So I'll just go ahead and start our server and the client for the database. That's a Cassandra.
You're starting the Cassandra software.
Yeah, Cassandra software. And we will also do the client here to interact and check the data from the Cassandra database. So here I have a key space. There is a table created here. This I will just check the, it's called Apache log.
Spell check, Apache.
Okay, so this is the structure of the table and we don't have any data here. So the log file we have seen, that message for each line will be split into specific columns like here, and then the data will be put into this table. Next, we will start the Apache Kafka. This is a messaging system. So let me start the Apache Kafka server. So for the Kafka, first we need to start a software called Zookeeper and then the Kafka server.
So don't get overwhelmed. Just starting it. Basically, I want to get an idea. Oh, okay. Data can be streamed. Data can be processed. Data can be stored in the Cassandra, some other softwares. Just to get the idea, when I talked about to you on the Lambda architecture, okay, enterprises wants to handle this data. So once this is done, I'll give a good idea on what is machine learning. That is where the real meat is. Okay.
Okay, so now we have done all of these. So what we will do, we will run the software now with the Spark job. So what this does is it will read that queue, what we call the messaging queue from Kafka as a stream, direct stream, process it, and then we will write it to the Cassandra database into a table. Okay, so this is just a small program which does all of this. Just give me a minute, Srini, 1 minute.
Yeah, no problem. So the companies collect a lot of data in the form of logs. They could be web logs, there could be any events. Even if in LinkedIn, there is multiple systems. When you send a message to a colleague or someone on the LinkedIn, just give me a minute. I think it's a little bit disturbance.
Yeah.
Yeah, okay.
I'm back.
Please.
So first what we will do, we will run the Spark job. So this will be listening to the queue and reading whatever data that is coming in the queue from the Kafka, process it here, and then write it to the Cassandra, our table, Apache log. This is the table we set, right? So we will start this job now.
One question.
Yeah.
How are you inserting this data to Kafka?
That I will show you. What we will do, we will directly ingest the file into the Kafka stream from the console producer.
Okay.
So there are a lot of different ways to put data into Kafka streams, but for now we will use only the client Kafka producer which we have.
I have a different systems can publish to Kafka. Like Golden Gate, Oracle Golden Gate. So third part, I mean, different those.
You have Kafka streams
start
as well.
publishing it. Whereas just for demo, he is just on console, he is trying to paste.
Yeah.
So are you running, Harun?
Yeah, I'm running. 1 minute. I think we do not have batch 8. Okay. First, I need to start this, create the topic. That
okay,
is
just hold on. Then Harun, give me control. You just to prepare at one point. We'll share that. I want to get them some more insights on machine learning. So give me control. You can meanwhile you check, and after some time we'll show them.
Yeah, I think that's a good idea because going into so much of in-depth, sorry, this Hari here, in-depth of the programming, we are also getting little lost.
Yeah, Harun, see, the whole idea is not that, not how to start, not how to just actually, just to get them, hey, data is flowing. Okay, this is great, actually.
Okay.
So, but don't worry, I'll give you the control. Just to give me the control. Okay. Okay, guys, let me share my screen. So there'll be, so idea is companies are interested in this data, but data that's the foundation. That is a small part of really the enterprise AI. Because now after you get this data, how you handle the machine learning, how you handle deep learning, what exactly it is, how companies take a decision, that is the whole class of this. So that's where let's get into this, I guess. Okay, what is machine learning? Everyone, I request you to focus. Please see, this is the idea. Whenever we say them, you might have heard this word from many people. You might have got some idea, but at the same time, some of you might have got confused also. Let me give you a very easy understanding. See, the whole idea of machine learning is machine learning from the data. Please understand. That's why they're called learning machines, learning from data. So what does it mean by learning from data? What is the meaning of learning from data? That is number one question. Number two, okay, what after learning from the data, the way we should learn, the way the machine should learn. After learning from the data, what these machines do? These two questions are important. What is machine learning? After learning, what it will do? Is that relevant question, Basavaraj? Why we should learn? Okay, please look here. See, first of all, let's answer second question. Say a machine learn from the data. Why it should learn? Okay, when it learn, it gets some insight. Based on the insight, it can do something. It can help you to do something. So what does it mean? Look here. Say your company has a data about customers. Come here. Data means you need to think like this. A data in your company about a customer, you can think it as a point. As a point. Data is a point. I want everyone to get this point. Mohan, suppose your customer has a customer ID and customer has a customer age. Don't you think it is like a coordinates x1, y1? It's a two-dimensional point, right?
Yes.
In mathematics, you might have seen x1, y1, or rather x, y, g is
Yeah.
a three-dimensional point. So you need to think like a customer ID, customer age, how long the customer is with your company is a three-dimensional point. So it means a record about a customer, you should imagine as a point. So in the machine learning, we'll be using that particular aspect very well, very much. So imagine here data means it is about the customer's points, or housing prices, or stock prices. This is the stock price. This is the stock price, stock price, stock price, stock price. Okay, there is one stock, say Apple or Amazon or some other stock. This is the historic values of the stock. So you want to predict what will be its stock price in future, or in 5 months, in 6 months. So you want to predict. So that is the need. So predicting is the need. So how you meet the need? See, if you have a straight line, if you extend this straight line, you know the future. So the idea is to predict the future. So to predict the future, how you predict? You need a straight line. So to get that straight line, what does it mean by to get the straight line? You would get the straight line based on these points. So getting that straight line is a learning. Getting that straight line means getting the slope of the straight line. It's a simple math. A straight line will have a slope. So the straight line may be this side or this side or this side. But a correct learning means a straight line which is almost equidistant from these points. So whenever you say the machine is learning, it is nothing but it is learning from these data, to take in this case. In this case, the problem is predicting the future. Predicting the future is one type of problem. There may be another type of problems called grouping the customers. There may be another type of problem called classification problem. Dividing the data. What does it mean by dividing the data? It means classifying the data. Say you are getting a mail. The mail may be spam mail or no spam mail. Or you may be having customers. Grouping the customers into 10 groups. You don't know what is the criteria. I want 5 groups of customers. Can you make it? I have 10 million customers, just make 10 groups. Some people may say a simple divide the customers based on state, divide the customers based on age. But that is a simple grouping. Whereas if you give the data to the machine can group it more intelligently. So that is where the machines has to learn from the data comes into the picture. So let me come to this problem again. So regression is one of the problem in a company where that type of problems are called prediction problems. Predicting the stock prices, predicting the housing prices, predicting the elections. So based on the data, when you give the data to a machine means a program, the program start learning from the data. So the learning means here building a straight line. So it means the machine sees this data points. Okay, let us draw a straight line that is passing through all these points. Because you know the straight line cannot pass through all the points. It can only equidistant for these points. It doesn't literally draw the straight line. It knows the straight line. So in this case, the machine learning from the data means knowing the slope of the straight line. So it is actually, when you say machine learning here, it is a mathematical problem. You might have already done in your college a problem called forecasting. Forecasting problem means you draw a straight line passing through these points, but equidistant to the points. Where the distance is minimum, you minimize the distance, you find the slope of the straight line. So that straight line, once you know the slope of the straight line, you can know the feature. It says just y is equal to mx, y is equal to 5x, y is equal to 4x, y is equal to 3x. That 5, 3, 2, that is what the slope of the straight line. So then you may ask me, do I need to write all this math code in this? No. Interestingly, all this coding is done in the libraries. So you take that libraries, you apply those libraries on the data, then that libraries will give you the slope or give you the model. They call it as a model. So let me summarize here. So you apply the libraries on this data, when you apply that, you get a model. You get a model. So you get the model out of the historical data, Mohan. You get the model out of this historical data. Then what do you use that? What do you do with that model? You use that model. Using that, you predict the future. Suppose say y is equal to 5x. 5x is the model. It means 5 is the one your machine learned. I'm just giving a simple example. Now tell me, if x is equal to 10, what is y? Mohan, if x is equal to 10, then y is equal to 5x, y is equal to 5 multiplication 10, which is 50
times. Yeah.
So if x is equal to 1000, it is 5000. So, but you may have a points up to 1, 2, 3, 4, 5, up to only 100. So from 100 points it learned, but up to 200 points it can predict. That is what the prediction means in the regression. That is only one type of problem, but the process is the same. Machine learning from the data. In this case, since this is a prediction problem, your machine is learning from the data, creating the model. That model is a regression model. Regression model means it is trying to do a curve fitting. It is learning, it is creating that model, then you apply this model and predict. That is number one. Now come here. This is second type of machine learning problem. In lot of applications, you apply for a credit card, either they approve or deny. You apply for a college, they approve or deny. You housing loan, approve or deny. You get a mail, a spam or no spam. You have some in hospital, there are cancer cells. Good cancer cells or bad cancer cells. So your machine run on top of the historical data and can identify a straight line which separates these points. That is the model here. So your model, your algorithm changes depending upon what problem you are solving. In this case, our problem is predicting the future, whereas in this case, classifying the data. Say you have let us take a bank. They have all the data, historical data of approved loans and rejected loans. Say this is approved loans and this is rejected loans. So you wrote a machine learning program where you took the libraries, the mathematical libraries or machine learning libraries. You don't code the whole mathematics here. People from CMU, people from Stanford who are studying deep computer science, they code the libraries and give to us. We take those libraries and apply in the real jobs. That's why many times it is called applied machine learning. Okay, so what is happening? Your machine learning program that you imported the libraries and the small program you are writing, many times machine learning programs are very small programs. You run on this historical data. So in this case, oh, okay, your bank has so many rejected applications already, so many approved. It will look, hey, what are the rules for the approvals? What are the rules for the rejections? Like, hey, this is the credit score, this is the salary, this is the debt ratio, this many years they are living in US, and this is their visa status. It could be, those are the rules. Those rules you won't code. The machine looking at the data, those rules are already there hiding in the data. So those rules machine will identify, then separates it has a line. It separates these 2 points. It means it learned from this data. Now what we should do after learning? Okay, now you apply this on the new application. When the new application comes, Mohan, Suvir, DK, Raju and other friends, when the new application for the loan comes into the bank, the transaction goes to this model. Yes, this transaction will be either fall into this, because the transaction is also a data. Should either fall here or here. If it falls here, your machine will say, hey, you approve this. If it falls here, you deny this. So it means it has drawn a line already. So the drawing a line separating these 2 points is a learning. But what type of learning problem it is? It is a classification problem. So your machine learning problems falls into different categories. So if you go to a company, you understand the problem. You need to understand it's a prediction problem. Are you predicting some value of the future? are you classifying? Yes or no is not a prediction. It is, though people say prediction, but you are not predicting the value. You are classifying either approve or deny. So again, to summarize, you have data that is historical data. It could be 1 gig, it could be 2 gig, it could be 10 gig, whatever the data they have. So you import some machine learning libraries. If the problem is prediction of value, you import the regression libraries. If it is a classification problems, you import classification algorithm libraries, machine learning libraries. These are created by excellent computer science people given to us. We are doing applied machine learning. We are applying into problem. So you import that library and apply on the historical data. So then you get a model. You get a model means you get a straight line that separates these points. Then you apply that model on the new transaction. The new transactions either falls into this, that's how it classifies. It means it is solving the problem. So it machine learn it, machine is applying into real-time problem. But of course, in between, there is a validating the efficiency of this model, etc. Those things will be there that you can learn in the class. But Mohan, please note, you asked a question, 1 gig. Yes, when you are learning from the 1 gig, if the outcome, the efficiency of the model is, it can be 60% or 70% or 90%. If it is 60%, you will say we need more. Right now, our machine learning problem can predict 60% of cases. In 60% of cases, it is right. Okay, you give more data. Okay, now 70% of cases, it is more right. Give more data. 80% of time, it is correct. So how you get more data? As the time passes by, you get more data. Today you have 1 million customers. You learn from this 1 million customers data. Our bank has million loan applications. After 1 year, they may have 2 millions. After 5 years, they may have 10 millions. The data growing. So as it learns more, that's why it's called machine learning. Not only learning from the data, learning over a period of time, learning from 1 year data, learn from 2 years data, 3 years data, but even learning from every day. Every day, your program learns. Sometimes it make a mistake. Swear, a patient cell came application, you approved it. Actually, you are supposed to deny it, but you approved it. But it's okay, that is some risk. Some applications you are supposed to reject, but you approved. Okay, there is some risk involved. But then they will evaluate the next day, even though after they approved it, okay, we approved it, but I think we made a mistake. Let us correct it. Let us correct it. Okay, next time when we are approving, let's not make again this mistake. So that is what the learning means. The machine learns from the historical data, and going forward, it applies on the new data and gives the outcome. The outcome can be 60% correct, 70% correct, 80% correct, 90% correct, 98% correct. You see, 5 years back, the voice recognition applications like Siri and Google Voice, they're only 70% correct. Every time you talk to them, it might say, I don't understand. But they improved it. They improved it on more data. They learned, the machines have learned it. And over a period of time, now almost 90% of cases, it's correct. So machine learning, when you say, it depends on the problem. What type of machine learning problem you are solving? Is a regression problem or classification problem? A lot of problems falls into this. Take another case. Another case of the machine learning problems is a clustering. Your company has a data. Yeah, please.
Sorry for interrupt. I have one question. What I understand from past 5 minutes or 10 minutes.
Please.
For example, in 2000 year, the banks, US government banks, they decide if you have a credit score is 700, we can approve the loan or credit card, for example. Okay, it doesn't matter like your H1 or green card doesn't matter. So they categorize and they can follow the process to approve or deny. After 2 years, machine learning, you give the application of Mohan, but he have like a 750 credit score, but it's denied because they changed the rules. Because H1 people don't give the credit cards, or maybe they changed some certain rules.
Correct.
Okay, so program we have to change our algorithm will automatically understand. Okay, nowadays who gave the credit cards for H1 categories, they are not paying back. That's why we are rejecting these people or something. It automatically analyze.
Very good question. I'll address that when I talk the deep learning. But quickly to inform you, that is called bias. So what happens is you learn from the data, but now hey, some rule changed. So that rules are not stored in the data, right? So, so you introduce the bias into the system. You introduce a bias. Okay, let's put this bias. Let's put this bias. Hey, let's put there should be citizen. So for citizen it is 1, non-citizen it is 0. Usually they pass the numerical biases, 1. Now next another thing, we pass another bias. So they are called biases. So they introduce the biases into the system. So that's where the machine will be learned. Does that answer your question, Mohan?
Yeah, got it.
I'll talk it. Let's move forward, guys. So,
Srini,
yeah.
I do have a question. So, so basically, so here, like, because the rules are not very simple, because, okay, from historical data and we know the rules, we can apply those rules to the incoming data and see which application can be rejected and which can be approved. But those rules can be very, very complicated, and that's why machine learning libraries are used. Like,
okay, that is very good question. Yes, exactly. You are right. You hit the bullseye, Kiran. See, historically, these rules are written in the code itself. Like if this person is US citizen, if they have this house, or if they have a job, then apply or deny. But what happens is, as the data is growing lot, as the business rules are changing lot, and even companies want to serve these rules, they want to be a little bit flexible, but at the same time efficient. They don't want to code everything in the code itself, all the rules. There sometimes some rules are not known, especially in the case of like fraud. Credit card fraud is there, the credit card transactions. They cannot put rule if the card is used like this, deny it, etc. So all these lot of rules are hidden in the data itself. So that is called treasure. So if you have millions and millions of historical data, now what happens is in the companies also, banks, the managers change, rules change. Some people forget last 10 to 20 years how the banks are working. Sometimes there is a valuable data inside. Even why we go and ask a lot of our friends for advices, because they use their experiences of the data and they will share it to us. So that is where instead of writing all the rules in the program, you give this the libraries, you take these libraries and apply on the data. These libraries, they use mathematical techniques, scientifically proven techniques based on the problem. For the regression libraries, for the classification libraries. And the clustering is one example, where you want to cluster groups, 10 groups, 4 groups, 5 groups, 15 groups. You don't even tell to the system what are the rules to group. Just give million customers and tell to the system, hey, can you make 5 groups? Can you make 10 groups? It uses its own mathematical techniques to group. Of course, I'll talk about this when I give a demo, how various groupings are done. So you're absolutely right, Kiran. The companies and the data is growing so much, and the lot of things can't be coded. So that is where these techniques are more popular. Especially, there will be a lot of complicated learnings, especially in the weather monitoring. the data may be 1,000 dimensional. 1,000 dimensional means each column is a dimension. If you have a row of 4 columns, it is a 4 dimension. If a row of 10 columns, it's a 10 dimension. A row of 1,000 columns can be there, especially in the what you call electron scientific experiments people do, especially when the people launch rockets when are finding planets, or even the customer fraud is so much complicated fraud, etc. Those rules nobody knows. That is where machines can do very, very complicated learning, especially when I discuss with you deep learning. Even this machine learning does 60 to 70% of problems in the enterprise, but deep learning solve more deep, complicated problems also, because it uses neural networks. They learn very, very fine way. I'll discuss about that. Kiran, does that answer your question?
It does. I actually have another question. I don't want to take too much time. So are there finite number of libraries like at a high level, or like I understand they might not have discovered everything?
No. Interestingly, these 4 problems, regression libraries, clustering is clustering. There is another, this one you see here. This type of problems everyone knows, right? You go to Amazon, these are called recommendations, product recommendations. Customers who bought this item also bought these items. See, in Netflix recommendations are customers' recommendations, rather companies recommend products. So these are called, they use the recommendation algorithms. You go to your website, you are trying to buy a book, Amazon recommends, hey, you may like this. So they compare your profiles with the other people profile, what they liked, probably you may like it. Even the Spotify music recommendations, they recommend, hey, you want to listen this song? This is a big business. Actually, Amazon says they did a sales of $10 billion just based on the recommendations. So regression algorithms, clustering algorithms, classification algorithms, and what you call product recommendation algorithms. These 4 algorithms are 60% of problems you can solve in the industry. Generally, when you go to job, at least first 2 years, I don't think you will be working anything other than these 4 libraries. Kiran, does it help you?
Yes, thank you.
Okay, guys, you'll be learning some basic statistics also in the class, but don't get scared if you're in math. You will not be coding the math. Math is already there in the libraries. You'll be only applying them. Okay.
Srini, one question.
Give me 1 second. Let me go. Okay, let me touch this, then I'll take your question. Anomaly detection is one thing. You know, people attacking your company's access into your network. See, how they do it is, of course, I'll be talking this even after the break. See, usually most of the transactions fall into certain groups. Your company employees, external or B2B transactions, they form into groups. When something strange or somebody trying to access into your network, the machine sees whether this falls into this, or falls into some other group. If it doesn't fall into any of those groups, there could be 2 groups, 3 groups, or 4 groups, which these groups are formed based on history. Historically, the employees access our network like this. But when the new guy is coming, they immediately put it as outlier. Okay, stop this network. Somebody is trying to access it. No, this may be even genuine transaction, genuine network access, but somehow this is outlier. They stop it. So that's how nowadays the anomaly detection, fraud detection, cyber threats, access, all this machine learning is heavily used. Okay, I'll be talking about this. Now, okay, this and this I'll be talking during the demo. Okay, now I take the question before I go to deep learning concepts. Please.
Yes, Srini.
Yeah.
To apply these machine learning algorithms, do we need the data in one data store? Like Cassandra, you are trying to bring all the logs into Cassandra and then process, right?
Yeah.
So, or is there any other way where we can directly read from the logs or streaming systems like Kafka? and apply these machine learning techniques?
That is a good question. That is a little bit advanced problem. Yes, there is a, you can apply machine learning on the streaming itself as it is streaming. It can, it already has, see, you have to learn from history, definitely, right? First of all, like the Cassandra.
Like in microservice world, we don't have the data at one place, right? Like different components own different data. If we want to apply all these algorithms in among all those data sources,
yeah, that is where
all
they
together?
architect like that. What they do is, for historical data, they won't look into multiple systems. Maybe 2 systems they might look. But what they do is they consolidate the data. That is where there is a concept called data lake. Even though your data is there in multiple systems, the data is there from the transactional point of view. But from the analytics point of view, what they do is they consolidate everything through Kafka and bring it into either Hadoop or Cassandra. But hold on, there they use it as historical data and learn. The model is learned there. But that is not the end. That is only a one level of learning. Then they apply this model on the streaming data. Okay? On the streaming data. When it is streaming, they take a decision, number one, because you have to take a decision, yes or no, or predict. Not only they take a decision, but also learn from it in real time. Are you getting what I'm saying? It predicts, but it can learn then and there itself. It means the model is getting updated then and there itself. You see? So it is, the learning doesn't happen looking at multiple systems, because the learning takes, especially the learning on the historical data, might take sometimes hours. It might take hours because it has to look into millions or 2 millions or 5 millions of data. Not only number of records, it has to look the number of dimensions. Next is, it should do number of iterations. Because after the break, I will tell you how it groups. In the machine learning world, it has to do number of iterations. Iteration 1, iteration 2, iteration 3. The learning doesn't happen just looking at the data. No, it has to run a lot of iterations. I don't know if you anyone remember in your either MCA or engineering, when you do optimization, operations research, optimization, or linear programming, they call it as a numerical analysis, numerical techniques to solve the problems. When they do numerical techniques, they do steps and steps, they do iterations, they do trial and error. They do iteration 1, then iteration 1 output they will put it as inputs, iteration 2, iteration 3 output is put into iteration 4. Like that it does. So Hema, what they do is they bring this data 99% into memory actually. You know, they don't even read from the disk. Disk they read once, they put in the memory. After the memory, they do iteration 1, iteration 2, iteration 3, everything in the memory. And that is where actually Hadoop MapReduce historically tried to do machine learning, but they failed because MapReduce is a programming technique where you have to write to the disk Hema every time. You have to, IO operations are a lot. You have to read, write, read, write. For every iterations, if you have to read and write to the disk, it's going to be very, very slow. Some of these machine learning iterations, sometimes you will have to do 1,000 iterations to improve, to come to the model. Did you get Hema?
So we have techniques to analyze the data which is coming from streams as well, right?
Yeah. It is. Okay. It's called even stream machine learning.
Okay. Thank you.
Okay, guys, I'll take a few more questions, but okay, on the machine learning, I have a, what you call, I'll have a demo after some time. But any other questions before I go to deep learning, ideas on deep learning? But to summarize, machine learning is a set of problems you'll be solving. You'll be solving the recommendation problems. You'll be using recommendation algorithms. The code you will be writing will not be more than 20 or 25 lines of code, because a lot of code is written in the libraries itself. Kiran asked a good question. All these libraries are so many. Not so many. There are so many, but these 4 machine learning categorization problems are very much used by the companies. You go to a company to solve a clustering problem. You go to a company to solve the classification problem. You go solve a regression problem, product recommendations. Or you may go to a company where they just do this product recommendation. You join Amazon or Flipkart or some other Apple, where you belong to a recommendation, a product recommendation team. Maybe next 2 years, you may be working on just this particular machine learning problem. But in that problem itself, you need to improve a lot, multiple versions of the project, a lot of other things. I'll show you quickly before we take the break and before we take questions. And give me 1 second. I'll take the question. Yeah, here you see. This is a very good, I thought of showing this slide when I talk about natural language processing. See, Toyota has done this big data history. They started in 2010, just analyzing the product quality. The products are good or not, how, etc. They were doing analytics. They were using 60 million records. In 2011, they started using big data and some machine learning techniques to analyze marketing and incentive analytics, to give promotions to the customers. They were using 70 million. This is also product quality analytics version 2. This is version 1. This is version 2, HEMA, 2012. And 2013, they launched interesting big data and machine learning project. It's called Customer 360. Toyota Social Media Intelligence Center. They pull the data from the social media, like Facebook, from the Twitter, what they are talking about Toyota products. Somebody say brake is failing, somebody is saying it's making sound, somebody is saying a problem with the accelerator, etc. They started analyzing and addressing the problems based on 500 million records. In the next version, they upgraded to customer experience analytics. They started using 70 million records. See here, 360 customer, same project actually. Next generation insights. You are using 6 billion records. So these are the versions. You may be in this project. It is NLP related project. You may be version 1, 2013. You may be working even 5 to 6 years, solving only one type of problems, but different versions of the projects. Does that help you, Hema? Kiran?
Yeah.
Okay. So these are the broad, these 4, in your resume, your research also, you'll be focusing on these 4 machine learning techniques, and 60 to 80% of problems, machine learning problems, falls into this category. Any question, guys, before we take a break?
Srini, one question.
Yeah.
Basically, the current system also, many of the products are built on the machine learning problems, right? So what especially we are going to be learning the new things, because only the regarding the Python the language change, or maybe something else right now is going to be built on the data. So the data, earlier also I saw that there are some products which will be learned from the data, the machines, right? So what's exactly, I want to understand that what exactly we need to see in future, like what's the difference in the existing system in the future system?
Okay, very good. See, these are getting concreted. That's a very good question. See, what happens is historically they started learning. One is, number one, data was less. Number two, the tools they are using are not scalable tools. Like they'll be using like simple Python and scikit tools, or R and some other tools. They run on the Excels, or they run on simple databases like Oracle and some other SQL Server, analytics SQL servers, or data warehousing systems. They access those systems, try to do some learning. Now what is happening is they are consolidating into the big data platforms. So that's why it is called enterprise AI, enterprise machine learning, or large scale. They call it as a large scale machine learning. Instead of accessing those multiple systems data, you'll be accessing data from Hadoop, or from Elasticsearch, from what you call Cassandra. You'll be accessing using Spark and Scala or PySpark. then applying the machine learning libraries of Spark MLlib. Spark MLlib. There are a lot of scikit-ML libs, R-based machine learning libraries, the Spark-based machine learning libraries, some C++ based things. They're getting consolidated with this open source. So the learning techniques are the same, but they became more sophisticated, and you will be learning in the class these what you call these machine learning techniques, which a lot of people are trying to do, but you'll be using a scalable machine learning techniques. Because if you talk to Vijay talked to me once. He was working in Visa. He has a PhD people who know very good machine learning, but when they are applying those techniques on the large data, they don't have tools. They don't have their tools doesn't run on these clusters. So you will be applying this Spark MLlib and of regression algorithms, clustering libraries of MLlib, and classification MLlib, product recommendation MLlib. And those techniques, you will be learning those techniques very clearly and applying them, and to produce the results. You will be learning the process to apply a machine learning projects. Let me show this slide to answer Chana's question. That's a very good question. So this is a standard process people use. You get the data. So if you are using large-scale machine learning, you won't get the data on Excels and apply machine learning. So you'll be accessing Hadoop-related systems, streaming systems, or these particular Cassandra-related system. When you clean and prepare data, you'll be handling the big data. You train the model. This process is the same. Anyone do any libraries or any tools, it is the same process. So train the model. What libraries are you using? So where you are applying, then the test data and improve it. The cycle goes. Chana, does it answer your question?
Yeah, I got you, Srini. Basically, you mean to say that because of the technology change, they want to apply the tools or whatever the machine learning technologies is based on the cloud, right?
Exactly.
Okay. Got you. Thank you, sir.
Very good. Any other question before we take the break?
Srini, I have a last question. Maybe it's not technical. So now I got like some idea what is AI and why we have to use to solve the future issues. You can predict before and you can do it like automated and solving, right?
Yeah.
For example, if you take one scenario, everyone knows aware about the Bitcoin. Okay, in 2017 April or maybe mid of the year, they predict Bitcoin will go like a 20,000 or 40,000. Everyone bought. Now it went down. So it's algorithm mistake. So now can I believe our algorithm like AI thinks what it's doing? Is it correct or is wrong?
Okay, see, that's a good question. See, again, AI is not what you call like they say it's a magic. See, they apply selectively. See, you may not be able to predict everything. See, they predict selectively. See, what this is, if company is predicting, what company's interest? Company want to predict, hey, who are the customers that can leave our company? Okay, Mohan? So that is their prediction problem. Their prediction problem is not Bitcoin prediction problem. So you join a company, Apple or some credit card company. They say, hey, who are the people who are going to deactivate their credit cards? Then you will see, hey, what are the complaints they have given last 3-5 years? What are the pain points? I tell you my case. I used to use American Express card when I came to US. I love that card. Once I forgot to pay the bill in time. The payment date is some weird date, some 17th or something. I usually pay 15th or first week. So then that I paid the fine, some $20 or something. Then I asked that guy, hey, 17 is weird date. Can you change it to first week or either 15th or something like that? And then my system doesn't allow me change the date, he said, Trust me, the last 17 years, I never used American Express card. I still have, every time I get a card. So anyway, the prediction problem is there. Who are the customers? So I called them. The voice, they recorded the voice. They know, they wrote in this, hey, Srini Vemula called this company, American Express. He has a pain point that he want to change it, and our company doesn't want to change the date. Well, probably that is the cause these guys start using. Like that, your company can predict. So your prediction of AI is not to predict everything in the world. Does it help?
Okay. Yeah. Okay.
Okay, guys. See, I think Harun, sorry, I think we're short of time. That's why we can't see what you're going to do. We have a lot of stuff. See, we are going to discuss the artificial intelligence, especially the neural networks. This is a very, very interesting. Very few people really understand, actually. So we need to move forward. Then we have natural language processing. So we'll take a break. Now it is almost 11:05 of 10:05 California time. We take 10 minutes break. 10:15 of California time, we'll come back. Then we'll spend 20 minutes on the what you call deep learning, which is called neural networks. It's based on the brain. The learning techniques are designed based on the brain. Then you'll talk about natural language processing. So everything we need to do in 30 minutes. Then we have a demo. Then we'll take the questions. So let's respect the time. Some people dialing from India also. We need to close in time, less than 3 hours. So, but let's take a break. Any questions? Any other questions before take break? Okay, wonderful. Let's take a break. Okay, thank you. Okay, welcome back. Hope you can hear me. Let me check quickly if I'm mute or something. Hema, can you hear me?
Yes.
Anyone? Okay, yeah. Wonderful. Okay, great. Our friends will be joining, but let's get into next 20-30 minutes is I request a rapt attention because these concepts are very new to most of you, and it's very difficult to understand by discussing with people and looking at videos and reading books. But they're very, very interesting and not too complicated, but still it takes time and energy to focus to understand. But these are the great concepts actually. Now what next? Of course, till now you got a base of especially what is a learning machines, how they learn from the history of data and apply on the new to take decisions, different types of decisions. But there is another concept called deep learning, where they use some algorithms like our brain uses. They are based on our neural networks. Our brain has neurons. They have some algorithm, learning algorithms. They apply those algorithms and they call it as artificial neural networks. So there are neural networks, but artificial neural networks. As our friends joining, whoever there on the call, I want you to understand why we need deep learning. Why can't the machine learning common techniques, especially the 4 problems we highlighted, and few other problems, few other libraries can't solve these problems? Why we need deep learning? So what happens is, there are some problems, especially the classification, classifying this or that, or even image recognition. Say you go to your bank, you put a check. You know nowadays ATMs can read the numbers, how much you are depositing. They are handwritten numbers. People write handwriting differently. 1, 2, 3, 4, 5. They are same numbers, but Hema writes in one way, Srini writes in a way, DK writes in a way, Raju writes in a different way. So different hand digits. How the machines can recognize it's a 5 or 6 or 7, how they classify it. Those are not straightforward classification. You see, earlier classification is a straight line, but many times it need not be straight line. Emma, do you see this? See, imagine these are the cancer cells or some other classification. These green are one type of classification. Can you imagine drawing a line? It's not a straight line, right, Emma? You can't write a one straight line and divide them, right? Do you see that, Emma?
Yeah.
So you need a line that moves along this, along this, along this. It is a polynomial. It is not a straight line. It is a complex polynomial. And then again, it has to come here. It has to come here. Here, 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 here. Like that, it has to learn. This has to figure out a curve so that when it falls this side of the curve, that side of the curve. It's not a straight line. So those problems are deep problems, deep classification problems. Those cannot be learned. These cannot be solved by the algorithms that are generally available. So that is where these deep problems are solved by techniques called neural networks, artificial neural networks. They are created based on our brain. Our brain have a neural networks where each are neurons. This is a neuron, neuron. the neuron has a networks called dendrites. This one is connected to this. Each neuron is connected to multiple neurons. This is connected to this, this is connected to this, this is connected to this, this is connected to this. So the signals pass from one neuron to another neuron to another neuron to another. So when your brain sees something, you quickly identify, but in slow motion, if you see, it goes into steps. Hema, can I ask you a question? Hema, have you seen anything that is moving which you thought it is a snake? Hema, anytime?
Usually whenever it is so fast and quick in moving, we think that it is something like snake, right?
Exactly. So even though it is not a snake, you first think it is snake, immediately after some time, oh, it's not snake, you will say, right? Imagine that it's a whole slow motion. So the image goes to your brain because your brain has a model thinking that it is, see, everything that is moving, you don't think as snake, right? See, Hema, if you think everything moving snake every day, it's difficult to live, right? You are moving, a tree is moving, you won't think it's a snake, right?
Whenever it moves linear. So
exactly. No, there is no rule, actually. You can't say if this move, this is snake, this is moving. Your brain knows quickly. Hey, if some tree is moving, something is moving, which is moving more closely like a snake. Let us put that to Hema, okay? So let's not debate on very, very finite points. We will spend some time debate later. But you see, your brain knows as a model how a snake moves. So when you see something, when you see something close, you get scared. Hey man, this could be snake. But after some time, again, it knows, hey, no, this is not snake. So it doesn't do in a single shot. It goes to multiple neurons. Then it figures out, actually. That's how it is. We can talk hours and hours and hours on this, but we just have to talk 30 minutes now. So that's why let's focus on very important points. So the artificial neural networks are created to solve deep problems, which are very complex classification problems, something like this, where they can't classify. So the artificial neural networks, you can imagine like this. There will be input layer, what are the inputs that are coming. In the case of images, most of the time you use these techniques for the images recognition. So the images inputs comes in the form of pixels. I will talk about it. This is output where you decide whether the input is snake or not. Output. It passes in between into multiple layers like our brain. Multiple layers. So this is called hidden layer. Hidden neurons, neuron, hidden layer. From the artificial neural networks point, each neuron is nothing but a function, a software function, like a method, like a function which you calculate. So a deep neural network, the neural network has a layers. If there are more layers, Hema, they are called deep, right? This is a layer 1, layer 2, layer 2. So there is always one input layer, there is always one output layer. But there are hidden layers, layer 1, layer 2, layer 3. If these are more, they are called deep neural networks. You'll be surprised to know in some companies there are thousands hidden layers. Anyway, don't worry about that. Now go to fundamentals. We're going to discuss a few fundamentals, because people spend hours and hours and days and days even to get these fundamentals. But I'm bringing it to you in a very simple form. Please focus. See, let's focus on few basics. See, imagine this is again input, again the same. Please see here. Now take this. Assume these are input 1, 2, 3. Hema, I'll be checking with you a few questions. See here, this is connected to this using this connection. This is connected to this using this connection. This is connected to this using this connection. So this is connected by three lines. So these lines will have weights. Weights means some numbers like, hey, this is suppose input 1, 2, 3. Input, give a numerical value. Give a numerical value to this. It is called weight. It means 2, 3, 4, something like that, weights. Even now, this is connected to this. This is connected to these three. Now take these two, Hema. Now this is output. This is input. If you take these two, now see, this is connected to this. This is connected to this. This is connected. So again, take this. This is connected to this. This is connected to this. Is connected to this. Let me go to the next. Okay. So now take the example. I'm just putting few basics before I really give you gist. Input can be a number. 0.5, 0.6, 0.9, 0.3. Usually these are pixels. Pixels number. Let me jump to one slide. I think that will give a good idea. Okay. Whenever there is an image, if you put your check to a bank, or if post office is scanning your address, to which zip code it should send, it's a handwritten numbers, right, Hema? So a handwritten number, if it is black and white, they will have pixels. 28 pixels, 28 pixels. There can be more pixels also. Take this example. If it is a 9 look like this. So some may be dark, some may be bright, some may be gray. It's called grayscale. Grayscale means something is dark, it is 0. Emma? Something is purely bright, it is 1. Something is gray, it may fall in between 0 and 1. It can be 0.5, 0.6, 0.4. Hema, do you understand this, what I'm talking? Raju? DK? Are you getting this, what I'm talking?
Yeah.
Okay, I'll be checking it because sometimes if my voice is not heard or something. So basically, an image means a pixel. So for computer, for us, we see a number, but computer, it sees like this. For computer, these are just numbers. So it's like a matrix. It's like a matrix. Okay. Now, imagine those are the inputs. Whenever you give an image to a network, neural network, which is artificial neural network, which is nothing but, when you say artificial neural network, it is nothing but a software library plus program. That's it. So your software, the software you write, you use some libraries, deep learning libraries. That library takes some data inputs. This time it is not a general data, it is images. You can read images. When maybe some read function, read these images. When it reads, it nothing but it takes a pixels. So the pixels will be numbers, whatever I have shown you. Whatever I have shown you. So this image means 9 image, 0, 0. There are 28 to 28. Imagine this 2-dimensional decay, 2-dimensional numbers. Imagine it, flatten it as a single dimensional number. Then don't you think they are nothing but 784 numbers? Because it means 784 inputs, something like this. 784 inputs. So each input is a pixel. Okay, now I'm cutting to a simple this pixel to you. I'm taking a simple network just to show you an example. 0.5, 0.9, minus 0.3. Generally minus won't be there, but take just for mathematics understanding. These are inputs. Now these are the next layer network, neurons. Please focus on this. These connections are called weights. Look here. This H1 has a weight 1.0, minus 2.0, 2.0. It means from here to here, this connection has a weight 1.0. This connection has a weight minus 2.0. This connection has weight 2.0. Which means when the brain is working, the electrical signals will be passing to the brain from one cell to another. Those electrical signal charges will have some weights. It means what weight, at what weight it is communicating. Something like this. See, even our relations. You see, DK and Razu, we know each other almost 30 years. 30 years. So our weight is 30 years of relation. So the 30 number is a weight DK. So I know Channa and our friend Mohan last 3 years. So the weight is 3. I know Hema for 5 years. So weight is 5. So something like that. So the connection between two people is a weight. So that is what the understanding of the weight means. The weight. So each weight network, this line has a connections weight. So now come here, H1. So from here it is coming, with some weight, from here it is coming to some weight. So what is the net weight that is coming? Hema, the question to you. It's nothing but weighted sum, right? 1 into 5, look here, 0.5 into 1, this weight, 0.9 into minus 2.0, this weight, 0 minus 0.3 into this weight. So all these inputs coming to H1, this is called weighted sum. Input multiplication weight plus input multiplication with weight. It's called weighted sum. Hema, do you get that point? This point? This is weighted sum. Now imagine the weighted sum is coming here. So weighted sum comes to here. Weighted sum comes to here. So this is the weighted sum on H1. Don't worry about this. This is weighted sum on H2, weighted sum on H3. Everyone please hang on a little bit, because this is a little bit math involved, but only a little bit. Even 10th class people can understand. But it's amazing with this little bit simple math, how powerful artificial intelligence people are building. You'll be really, really, really surprised. Please look here, guys. So the inputs to H1 is weighted sum. Input H2 is weighted sum. So this sum is minus 1.9. This sum is, for H2 it is 3.1. For H3, there is a minus 0.4. So what they do is they use another technique. Weighted sum is one technique. They use some normalization. When you normalize it, your intelligence doesn't go down. What does it mean? Suppose you see a big mountain, Hema, you see a mountain from nearer. You can see the mountain from farther. Few things might be, clarity might go, but generally your understanding whether it is a mountain or whether it is a cloud, does it change? Your intelligence about mountain and cloud is the same, right? Whether it is far or nearer, Emma? Yes or no? Mohan? Somebody has to answer. I need to check.
Yes.
Yes.
You're right.
Yes, Srini.
Okay. So Shiva, please. So that is called normalization. When you normalize, your intelligence doesn't go. That is the technique they use. What they do is they don't like these numbers. 1.9, 3.1. Instead, when they normalize everything, they keep between 0 and 1. So how they can keep whatever the inputs that comes to H1, see, minus 1.9. You can normalize it to less than 1. How? Please see. Take this simple example of a function. Don't get scared, guys, by looking at this function. Oh, this is going to be mathematics. These are the fundamentals. They use this to build these libraries. Interestingly, we use those libraries to solve the problems. But I want to share you simple techniques they use. Look here, take this function, Siva, 1 by 1 plus e power minus t. This is called softmax functions. It's okay if you don't know the name. Look here how beautiful this function is. See, if t is big, 10, 100, 1000, what happens is e power minus infinite. If t is becoming bigger, Siva, e power infinite, e power 100, e power minus 100, this becomes 0. Please see. If t is becoming bigger, because this is minus, anything to the power of, even any number to the power, if power is big, it becomes big. But since it is minus, it becomes 0. So this becomes 0, whatever the value of x. Yes. So if this becomes 0, what happens? 1 by 1. Siva, how much? It's 1, right?
Yeah, maximum value is 1.
Exactly. Whatever the value, if you pass to this function, even if you pass 100 or 200, the maximum value is 1 only. Okay. Now, so let's go to minimum value. Minimum means minus infinity, right, Siva? Minus 1000. Okay. E power minus of minus becomes plus, right?
Right.
So, e power infinite means how much? E power infinite means infinite, right? Anything to the power, if power is infinite, is so big, it is infinite. So infinite plus 1 is infinite. 1 by infinite is 0, right?
Yeah.
So the minimum value, if you're passing negative values, it becomes 0. So the height is 0. 0 and maximum is 1 and minimum is 0. Let's go in between. Let's give 0. T is 0, Siva. Anything to the power of 0 is 1, right, Siva?
Right, Srini.
Hey, some people forgot, don't worry. Anything to the power of 0 is equal to 1, or you ask your kids, they will tell you. Anything to the power of 0 is 1. 5 to the power of 0 is 1. 5 to the power of 10 to the power of 0 is 1. So 1, Siva. So 1 plus 1 is 2, right?
Yeah, 1 by 2.
1 by 2 is 0.5. Look here. So maximum is 1, minimum is 0. The in-between value is 0.5. See the beauty of this function. So if you pass any value to this function, it will be between 0 and 1. So that is called sigmoid function. Look here, now I am passing, I'm getting this weighted sum, which is minus 1.9. I pass it to this sigmoid function, which is this function. I get this value, 0.13, 0.96, 0.4. So anything coming here, it may come thousands of data, thousands of weight total. But I normalize it, I get between 0 and 1. So the values of H1, H2, H3, Siva, do you agree? Anything between 0 and 1 only?
Right, Srini. Yeah.
Okay, now take this, these are the inputs now. Now again, they have weighted sum, right? This also weights. So when it comes to O1, look here, O1 has weights. Okay, let me go to next slide. See here, O1, Siva. O1 also has a weighted sum, right? If you pass that to sigmoid, don't you think output will be between 0 and 1? Again, there will be 0.
Yeah.
Anyway, so a neural network takes the inputs from the images. Now imagine, look here. Suppose you have hand digits 1 to 10. 1, 2, 3, 4, 9, and 0. So these are the 784 inputs will be coming from here. These are the network. When it comes to hidden layer, again they are between 0 and 1s. Again, these inputs are 0 and 1s. These are the grayscale images 0 and 1s. These are the 0 and 1s. These are the 0 and 1s. These are the ultimately the values also 0 and 1s. 0 and 1s. Now imagine, come on guys, focus. This is very, very interesting and very complicated for a lot of people. But let's not, it's very interesting. See here, the inputs doesn't change. Your images are, if you give 9, it is 9. Your input is fixed. but new inputs will be coming, that will be changing, I agree. But when you give it is 9, how can we make this is close to 1 and rest all close to 0? What does it mean? Let me come here. Look here. This is Panda. DK, Razu, Channa, everyone, please focus on this. Look here. This is Panda. This image is passing through a neural networks. But ultimately, look here. If it is giant panda, say the value is 0.9. Red panda, it is 0.05. Raccoon, it is 0.01. So if you have these outputs, Siva, is this a red panda, raccoon, or giant panda? 0.9, which is the maximum value, which is close to 1.
Yeah.
Close to 1 is giant panda, right, Siva?
Right, Srini.
Right, that is the important. See, the outputs, which is more close to 1, is the output. Now, see, I put 9 here, but this one, this node is more closer to 1 than this. So what does it mean, Siva? Don't you think there is an error in this network?
Right.
See, if I put 9, this value should be more close to 1, not this one, right? So the output should be accurate. But where is the control? This is the input. So it is passing. Where is the control? What is changing? What is changing is the weights. Look here. In this weights, these are the inputs, W1, A1. These are fixed. So suppose you give a 9. Everyone, please listen. This is very, very important. These are the inputs, A1, A2, A3. W1, W2, W3, the weights. Only changing weights, you can change the output. Siva, agree with me or not?
Yes, Srini. Yeah.
Suppose here, hey, I give an image 9. Instead of this one more close, suppose this is 4 is close. Don't you think my network is recognition intelligence is not learned properly? Then how can I make this one more close to 1? The only control I have is changing the weights, right?
Yeah.
That is the main catch. That is the main catch. Look here. If there are network many, this one, there are 784 weights for each one. 16. In this layer, there are 16 into 784 weights. Between these two, 16 into 16 weights. Between these two, 10 into 16 weights. So, Mohan, I told you about the bias. You can introduce a bias into the system if some rules are changed. So, in each layer, you can introduce biases also depending on it. So, this is 16 biases, this is 16 biases, sorry. This is 10 biases. So, totally 13,000 weights or 13,000 buttons. You can think as assume it is like your radio tuning. It can be changed. So what does it mean when you have an image? If it is 9, it should be 9. If it is 8, it should be 8. If it is 1, it is 1. It means you need to have weights that changed based on this image. But how those weights, what weights you need to give? So that is what is called learning, deep learning. In deep learning, what they do is you have many images. First, sorry, let me come back again. You have, say they have a test data. Say they have 100,000 images, which already they have labeled it. If it is 9 means 9. So they train this network on these images. So for the 9, they give it and train it. So they get an error. Suppose they get an error saying that, oh, 6 is activated, but not 9. Then they will change the weights. So this time they'll make sure 9. Okay, good. It's working for 9. Then they given 7. Again, they change the weights. They make sure 7 is working good. Again, one more thing. If it's 4 is working good, then no need to change. Like that, they train this network on many, many images so that they optimize these weights. Sometimes what happens is your network is good for 9, but your network failed for 4. It is like, some people say, right, you try to solve one problem, but you create another problem. So that's where, if these layers are, you have less layers, changing is very difficult. You change one thing, it fails in another image. You change one thing, it fails in another image. That's why you need a fine tuning. If you have many layers, you can change this, you can change this. Any change will have less effect. So that is what is called learning. So your neural networks, which is a software libraries and a basic code, you could write some 10 to 20 lines of code using those libraries. Those libraries read the images, read the what you call training images, say 50,000 images, and learn what weights this whole network should have. What are the 13,000 optimized weights? They train it. Then they test it on another 10,000 images, which they already know, and to check if the network is working good. Then they apply, the post office apply or the bank apply that model. When you say model, your network model is nothing but weights, right? Okay, these are good weights. These are optimized weights. You give an image, these weights make sure 9 becomes 9, 8 becomes 8, 8 becomes 8. That is what exactly. So your neural network learning. So it is a learning in the deep. It is learning in the deep layers. That is what it's called deep learning. It's called deep learning. So your deep learning means it's a artificial neural networks working in multiple layers, working on the images, building the models. Building the models means building the right weights, optimized weights, then apply on the images, on the new images to recognize well. So still it could be 90% of correct, 98% of correct. That is what learning, again, your machine learning, the ideas that we discussed earlier remains the same. Your learning continues. Earlier, Google Images and Facebook recognize your face. Earlier, it is 70% of cases it is right. Now it's almost 90% of cases it is right. They are aiming for 95, 96. So they'll be increasing. So the networks will be learning. That's how they may recognize the faces. Also, when a car is going, connected car or autonomous car is going, they classify it's a road or it is a human being, it is a signal, it's a red signal, blue signal, that signal, or a pedestrian is going, or some other car is a truck. So they classify it just like 1, 2, 3, 10 numbers. Shiva, I'm asking a question. When you drive, tell me, do you see, you may see 1,000 objects, but do they classify into 10,000 categories? Either there will be human beings, or you will see a car, or you will see a truck, or you will see a traffic light, or you will see anything you see?
Yeah.
How many categories you see?
Maybe like 10 or 15 categories.
Exactly. Just like the output layers will be 10 to 15 or 20. Those are, you may see objects, many objects, but they may fall into either human being, pedestrian, or traffic signal, like that, right? So like that, your car, when he is driving, it knows, it has already a model. It has a trained artificial neural networks with the weights, optimized weights, which they will be learning. That's how it's going. So this is a great techniques. This is real artificial intelligence, they call. It's a deep learning, which is based on artificial neural networks. So that is a brief understanding. What is on the people? Any questions on this? This is till now what you discussed on this. These aspects, weights, and then etc. If you have understood, you should really congratulate yourself. Now you go and see anything on the deep learning, artificial neural networks. You get really good sense. Siva, any questions on this before I go to?
Srini, one other
Yeah.
use case, is it like these days Amazon is asking us to scan a product image instead of barcode and try to, the app will search in its store. That is also through this image recognition.
Yes, exactly. Oh, this has so many applications. Even your Siri, voice recognition is on neural network. Your image recognition, neural network. Your cars is neural networks. Then
Even the iPhone X, it face recognition. It
your
doesn't know.
retina ID is this one. Even your thumb, what you call your
Fingerprint.
Fingerprint is based on neural networks. These are not simple machine learning algorithms.
Yeah, okay.
Okay, Mohan, any question? Channa, DK, Razu, Hema?
I have only one question, Srini.
Yeah, please.
Like you said, they're categorized based on what objects they're categorized. For example, if you see the objects when you are driving the car, how you say this is like a object, trees, this is road, this is signal. How you categorize based on any algorithm behind that one?
That's what I'm saying, right? They give the images in advance and train the models. All those models are already put in the. Suppose Google, you go to Google, they have so many images. They trained their algorithms on those images, labeled images. They already given the trees, multiple trees. Mostly, see, depending on the application, when you are driving, they just need to know tree. They don't need to know whether it is a banyan tree or another tree, whether it is a tree or a human being, like that, right? So all these images, labeled images, already they have given thousands of trees to the network, already trained those models. So, since the training means the network already learned, it means it has a optimized weights. So that weights, based on that weights, if you give any image, it can categorize. Just like your 1, 2, 3 to 10, how it categorizes, it can categorize whether it's a tree category or human beings, like that. Mohan, the answer?
Okay.
Channa?
Yeah.
Anyone? Hema? Any
Hello,
questions?
Srini?
Yeah. Okay, guys. I know we are crossing time. Just I might need 10 or 15 more minutes. Let me quickly pass now. Now, next is, okay, deep learning. Spark has a deep learning libraries that uses Python mainly with PySpark, but they run internally on top of TensorFlow, Google TensorFlow and Keras. These are workflows of the Google and some other universities libraries. They run on top of it. When you say on top of it, because Spark simplifies it. These TensorFlow and Keras are a little bit lower level. You have to write a lot of code to handle those libraries. Spark can take you to the next level, can reduce the code and more understanding in the enterprises. Companies are using these deep learning libraries. Next you go, very interesting area is NLP, natural language processing. Okay, you read images are okay, you read text, but can the machines understand these text? Can it understand the sentiment? Whether this person is talking good or bad. This is what sentiment analysis is, a technique for detecting how the customer is reacting to a product or brand, even a situation or event, either positively or negatively. When somebody is talking, even the voice case, you can discuss in the classes about the voice. If people are writing on the Twitter, what they write about a product, what sentiment is it? A bad sentiment, a good sentiment, or how can you quantify? Are they praising it at scale of 1 or 0 to 10, or is it 8% dissatisfied? All those things. Those are handled by a different techniques called natural language processing. For that, they need to, this machine should understand the meaning itself. They use certain keywords like bad, outrageous, certain things. There are sophisticated techniques. It's an evolving field, but it's a fairly good, applicable in the industry. There's a lot of applications. So look at Toyota has done a project to find out the customer feedbacks. So they collect the tweets. They hear if the brakes are making noise, or the wheel is making noise. Sometimes false positive. Somebody says, I went there. In future, I want to change the brakes. I want to change to brakes which has no squeak. So certain false positives also will be there. But whatever it is, these libraries, these natural language processing projects, you use this machine learning, not machine learning, natural, of course, the machine learning, deep learning under the hood, but it uses additional libraries called natural language libraries. So there are techniques. You take the raw text, you make them into words, then you convert them into vectors. There are hashing algorithms. Then you train the model. Certain techniques are there. Initially, in a first version, you may be 50% accurate. As you improve these techniques, you may go up to 80% accurate, different ways it is. I'm going a little bit faster to cover. So in our class, we'll be focusing on this also. We're focusing on big data handling, machine learning, on Scala, Spark, Spark MLlib, deep learning, Python, PySpark, and the TensorFlow Keras, and natural language processing. Spark has a natural language processing libraries which are in Python. They're not complicated. These codes are friendly. You import these libraries. Actually, in fact, it is only 3 lines code. You build a pipeline. You build a pipeline. It's called machine learning pipeline. You find out the sentiment using this pipeline, using the data. Of course, you get the data here. You feed the data, transform the data, you show the sentiment. But this pipeline has some functions. Document assembler, sentence detector, tokenizer, spell checker, sentiment detector, finisher. These are the functions. This is one finisher function, sentiment detector function, tokenizer function, sentence detector. So that's it. So simple. You import libraries, read the data, create a pipeline, create the sentiment. This pipeline has some functions, 1, 2, 3, 4, like that. These are beautiful. This is Python code. It looks like a Scala. So whoever knows Scala in our classes, they will be very comfortable. So first 5-6 weeks, you will be learning all the fundamentals. In that, you can even do NLP. So 4 categories: big data, machine learning, deep learning, NLP. All together forms the enterprise AI. But the process you follow is this: get data, clean and filter it, train the model, test it using your test data, then improve it. Because initially you may have 60% intelligence, 70% intelligence, 80% intelligence. Like that it moves. So if you permit me, I'll do a quick demo, maybe 5-10 minutes demo without going to syntax. Channa, is that all right?
Yes, Srini, I'm good.
Okay, I know there's a lot of stuff, so we need to go a little bit quick, that's why. So everyone please bear with me, but at the same time, I believe I'm going at a good pace. You guys are really doing good. So let me go here. I have a machine learning libraries, k-means, clusters, every code. Don't try to understand the code, understand the meaning. I'm just importing some libraries here. Let me run this cell. I'm attaching to this cloud. You will be in the class, you will be using this cloud. Yeah.
We are not able to see your desktop.
Okay, that's good. Thank you. I think the sharing aspect. Let me come here. Let me new share. Let me go here. Thank you. First, here itself, let me show you how we do it. Everyone, please bear with me. Look here. So what we are going to do is we are going to do a use case called anomaly detection. Anomaly detection means you have so many data that is clustered. something like this, clustered. First, I'll create those clusters. I have so much data. I'll take some of 10,000 records or something. I cluster it. Using clustering techniques, clustering libraries. Then I apply on the new data. If that new data either fall into this cluster, if it doesn't fall, it is outlier. That is the logic. Mohan, you understand? I group the data. If the new data, if it falls into in the group, it is not outlier.
Okay.
If it doesn't fall, it is outlier, which is anomaly. Okay.
Yeah.
So how I know it doesn't fall?
Based on your history.
Of course, I need to see the distance, right? The maximum distance. This is one cluster. This is one cluster. I take the maximum distance. Okay, this length. Okay.
Okay.
Anything fall around this more than this distance is outlier. Okay.
Okay.
Suppose this is here. If this distance is, I'm putting this as a threshold. If anything follow more than this distance is outlier. Okay. Okay. Let me go here. I have a libraries. I download libraries. I have some helper functions. Don't worry about this. I'll talk about this after a couple of minutes. But come here. I'm taking the data, some training data. First, I need to train. I'm taking the data. It becomes a RDD, Spark as a data structure called RDD.
Srini, again, we're not able to see your screen.
Okay, let me share it. Thank you. Okay, Mohan, can you see this?
Yes, Srini, now.
Okay, very good. Please look here, guys. I am running this. This is a libraries. I told you, right? ML libraries, you need to import. I'm importing clustering libraries because my idea is to cluster the groups. First, I need to cluster those groups. So that's why I'm using these libraries. In class, you will be learning. These are some functions I need, helper functions. I'll talk about them. Let's move forward. I'm reading some data first. This is a training data. I'm just reading text file. I'm reading the data. I'm just seeing how the data looks like. Taking few rows. The data has 3 columns. Mohan, this one, 3 columns. The five rows I printed. Okay, 3 columns. This one. Okay, this is just a categorization variable. Don't worry about this. So data is mainly this. So x1, y1, x2, y2, a 2-dimensional point. Okay, this data can be anything. It could be network data, like who is logging in, what are their some token numbers, etc. We simply now treat it as a number, which is a just point. So this is okay. Don't worry about it. Now for time's sake, I'm skipping that one. Now what this is I removed that last column, which I don't want. Now this is the data. Mohan, this is a 2-dimensional point, right? The 2 data.
Yes, sir. Yeah,
it's a point. See, I printed, I cached it. Now I just counting is okay. Counting, I have 2,000 rows, not too big data. This is where you see here. I am taking the model, a technique called K-means. K-means is a technique with which you cluster the groups. I will be discussing in the class. So
K-means algorithm.
Yeah, K-means algorithm. You're right. K-means you set some parameters. You run that K-means. That K-means you're running on top of the data, Mohan. This K-means where the model is created. This is only a K-means object. This K-means object you're running on the input data, the training data. So now you have the model. Here, how many clusters I did? See, I did 5 clusters. Please look here. Set K is equal to 5 means I want 5 groups, 5 clusters. So your clusters will have centers. So look here, my model, I created my model, a 5 cluster model. My model, each cluster will have a center, right? So look here. Center 1, 2, 3, like that. There are 5. Each center is a point. It has x1, y1 coordinate. See here, 1, 2, 3, 4, 5. 5 clusters. This is okay. Don't worry about this. This is just what point went to which. This is more important for you. See here, this one what it says is how many clusters. See, this is 0 cluster. 0 means 1. Second cluster, third cluster, fourth cluster, like that. In each cluster, these 458 points went to 0 cluster. 0 means first cluster. In 1, 427 points. For 2, see, these 336, 15, 239, these points went here. These points, they are different categories of the points. Second category, third category, fourth category. These categories of points went to the cluster. This one, here also there. Like that, this is just for information. Then see here, calculate the distance from the most distant element belong to the cluster and its centroid. So this one, what is the maximum distance? I told you, Mohan, we need to find out the maximum. These clusters are known. Out of that, what is the maximum distance of a point? I took the 2 points. One is, I call it as a threshold. One is maximum distance minus 5. Then I took the maximum distance. I want to use both because I want to see which is above maximum distance, which is 5 points before the maximum distance. Okay. So next I'm getting a training data. Give me 1 second. Filter through training data points to delete outliers. This okay. Don't worry about this because this I am trying to run on top of the existing data itself. But I mean existing training data itself. But usually you run the outlier on the new data. So I'm taking the new data. Mohan, I'm taking the new data. See, this is test data. Earlier it is training data. I'm running on the test data. So these are the categories of points. There are 109, 99 different points are there. Now I am going to run the, wait, what is this? This is just anomaly. Give me final label problem. This is where anomalies. Okay, this is again just you are splitting the data and preparing vectors. You need to prepare your data to run the algorithm. So this is where exactly your outliers are coming. See here, how many testing outlier detection with the following test data. So you have various categories of outliers here, 1, 2, 3, 4. But this is labels and domain anomalies. Actually, this we are running on the existing data itself. See here, what is this data? Let's go here. You see, test data. We need to run anomalies on the raw anomaly data. There may be a little bit confusion, but please hang with me. So filter through, yeah, this is where exactly you're running labels and anomalies is the one which is the new data. Let me go here. It may be a little bit confusing to you as I'm going very fast. Here. This is the raw anomaly data. From raw anomaly data, I got the labels and data anomaly by removing the unwanted column. So that is where exactly I'm going to run my anomaly. So which shows to me I have 3 anomalies. 3 anomalies. Because I'm using a maximum threshold. Mohan, if suppose I am running, I put 5 here. It means if my threshold I put not maximum, if I put it little bit less distance, let me see what will happen. See, Mohan, do you see? You got 109 anomalies.
Yeah.
Suppose see here, maximum threshold, I took only 2. Maximum threshold minus 2. It means I decrease the distance. More points will be, more outliers will be there. If I have a 100, I reduced a lot. 100, of course, we don't have. If I have 10, we'll have more anomalies. Okay, 240 anomalies. It means these 240 belongs to one of the group, right? It is falling into some groups. So if I remove this distance, if I have a maximum distance, it means only few outliers will be there. Lot of data will belongs to one of this cluster. Only few points are belongs to outside the cluster, which is anomaly. Of course, you can improve the cluster performance using cluster scoring techniques. I'm running this. This is for improving the cluster, improving the algorithm, I mean. What does it mean? It means you're running many Spark jobs. So what happens is, if a cluster is, sorry, if the cluster size is 1, 2, 3, 4, 5, 6. So which cluster, how many clusters you need to take? So this technique will help you. This clustering score, you can do a clustering score. For 1, it is 47, 2, it is 31. See, after some time, what happens? The clustering score will not be changing. See, it is 5.36, 3.5, 3.3, 3.9. See here, it is not changing here. See, from 47, it became 31. So wherever there is no change in the score, that you will take as the clustering score. So clustering size. So it is not this, if the size is clustering score is maximum, is not the efficient one. If clustering score should be minimum, the score is based on the distance. The distances should be very little for the groups. Don't you think you will say close-knit communities? Mohan, have you heard the word close-knit communities? You and your close friends, right? Your close friend distance is less. They're very close to me. So your score should be minimum. So that is what exactly. So based on looking here, the 10 or 11 or 12 sizes gives you more efficient machine learning clustering solution. So instead of 5, you will change this K to 12. So you will go to your algorithm again. You will change it instead of your model. You will change it instead of what you called, instead of k-means 5, you will change it to 12, so that you will rerun the model again. You will rerun the model, then you will train this. Look here, I'm training again now. This time I'm training. Now see, earlier I have cluster center, Mohan, I have 5 cluster centers because I have 5 clusters. 1, 2, 3, 4, 5. Now if I run, I'll get 12 clusters. Why? Because my k-means is 12, right? The k-means is 12. So this is the 1 cluster center. This is 2nd cluster center, 3rd center. I know it's very difficult to understand when I'm going such a fast, considering our time limitation. But anyway, it doesn't matter if you really understand the certain things I talked in the last 10 minutes. What you need to get the idea is, oh, okay, this is the process. That is how you build your engine. Here we are in fact building anomaly detection engine. See how powerful it is, you see, with which you can find anomalies of your network detection. If someone entering into network, you can find out. You can build a fraud detection on your in your company, on your products, on your services or customers. So the process remains the same. You collect the data, you import the libraries, you take the data, you train the model, you apply the model on this one. So the process remains the same. So give me a couple of minutes and finish it. So your techniques remains the same. This is what you will be applying in your machine learning. So summarizing this, you can able to build different engine as a AI engineer, as a data scientist. You can also call yourself as a data scientist if you do this. So you'll be applying this machine learning, deep learning, NLP techniques using big data. You'll be building a good engines, recommendation engines, prediction engines, classification engines, clustering engines, anomaly detection engines. More than anything, this deep learning engine, what you call engines, especially to identify the images, especially to identify the voices. So in our class, we'll be doing hands-on. The syllabus, it all falls into category big data, machine learning, deep learning, NLP techniques. It's called enterprise AI. You'll be learning a little bit of basic statistics also, how to connect to Cassandra. You'll be learning Scala and Spark. It goes to the a total 10 weeks, 10 to 12 weeks. So these two parts goes to 78 weeks. These two parts go to 3 to 4 weeks. Any questions? We'll close in 5 minutes. Mohan?
No, Srini, I'm good now.
DK, Razu, Ganesh?
Good.
How does it sound? Of course, I had to rush a little bit. You know how difficult covering these things in such short time. Anyone?
Right. What is the timings of the classes? Like every Saturday only, or you have some other days also?
Saturday and Sunday. Saturday 3 hours from 8 to same now whatever we done. Sunday it is going to be 2 to 2.5 hours.
The same time?
Yes, exactly same time. Saturday 2.5 hours to 3 hours maximum. Sunday 2 to 2.5 hours. Mohan, any other question you have? You don't have any question? You don't want to know how much is the fee?
I want to know, Srini.
Okay, just guess how much is the fee for the whole course.
I don't know, Srini.
Yes, man. Guessing, already attended.
It's $1,000 to 2,000 something
for the whole thing.
Yeah, because big data you're going to cover. I don't know. Really.
Okay, that's good. That's a good question. Okay. Anyway, this is it. So you have options. You have option to
okay. Almost
focus on this. Focus on this because this is big data, which is a consolidated version, which puts you as a machine learning engineer. Up to this, you can go to job if you want. But I encourage you, these concepts are very, very important, which give you a lot of edge in the market. So complete, it will be $2,199. So some of our friends, our old friends like Siva, this guy is Siva, who attended the first batch, they already paid some fees earlier. Some people paid. Sairam Garu, you're there? How much you paid for your last big data class?
$2,000.
$2,000. So you'll be paying $199. Okay.
Okay.
If someone, for reason some $1,500, they will be paying this one. If they are just learning this one, machine learning, I'll think about deep learning and later. It's free. It's free if somebody already attended my class. But they can even attend this. So I encourage you, this gives you good edge. You'll be hot hire. You can compete with anyone. And there are plenty of jobs. And everyone wants this. And the coding is not too complicated. But the ideas are very deep. Trust me, very deep. You start applying them, you will be very surprised. And the crowd with which you interact is a different crowd. Your colleagues, people with whom you talk will be a different crowd. So the ideas of big data, ideas of deep learning, ideas of what do you call natural language processing. So are the top techniques, top skills anyone is aspiring. So questions, last 2 minutes. So the session will start this coming Saturday. I really encourage you to join me. It's the 10 to 12 weeks. I'm very confident you don't find this well-designed curriculum, well-designed training anywhere in the world. I'm very confident. Because some people might teach Spark, they may be missing Cassandra connectors. Some people may be teaching machine learning, but they may not be teaching you Spark. Some people may be teaching you deep learning, they may be teaching R and little bit TensorFlow, but not some other machine learning techniques. Some people may be, of course, very few people, hardly anyone teach NLP, natural language processing. They may be teaching, but they may be using different libraries where many companies may not be interested. So it is a very optimized, well-researched and industry needed course, which is packaged very well. And the course is not pricey. Just want to encourage you, don't get discouraged. Just these concepts, these big data concepts, little bit enhanced. Even Sairam and a few other people who already paid $2,000. But these are on top of it. And you will be introduced new tools like Databricks Cloud, which I'm showing to you now. You'll be learning Scala, you'll be learning Python language that is related to this course. I won't make you expert in Python, but Python, Scala that is needed for this artificial intelligence. So Saturday, I welcome you, and you should encourage yourself. You should appreciate yourself to learn these things. This gives you a very powerful tool, powerful technique, and it can increase your growth very much, and your ability to find jobs will be very, very easier. I know you can even find jobs with these techniques itself, but it's all competition. Staying one step ahead is the secret, because these are not rocket science. People learn sooner or later. But even with this itself, you are one step ahead. With this, you are two steps ahead. With this, you are 3 steps ahead. So it is a simple, common sense. Just in the market, you need to be competitive. That's it. You need to be competitive. But the field is great field. You enter into this, you'll not be changing into next 10 to 20 years. I'm very confident. Field is absolutely great. In the field, you want to settle with this? No, you might have already competition. But if you have done it 2 years back, 1 year back, this is good. Even now you can find jobs here, but you need to sweat a little bit. You add this, you are good in the market. But I suggest you, because people hire about your knowledge also. Hey, this is good, but you already know this? Wow, that is great. Come on, let me hire him. So we also do some little bit research in these areas, so you can associate. So when you put your resumes, you can mention that you are collaborating with my company, iGebra, which is a training and research companies in this. So absolutely, I can help you to build an excellent career in this. Okay, guys, the last 30 seconds. Any questions?
One question, Srini.
Yeah.
Will you be giving a certificate based on this syllabus that we have completed this course with your training?
That is very interesting. Yeah, I collaborate with Digital Ready, who gives certificates on the digital marketing. So this year, till now I didn't issue any certificates, only a couple of certificates to Siva and few friends because the company wants I gave, but I'm giving a certificate from iGebra as an enterprise artificial intelligence. So at the end of this course, you will have a certification that you done with me, and you will have references personally signed. I work in University of Arizona. I interact with many research teams, open source teams. So I'll be continuing my research on this. So our collaboration will add a lot of value for you.
Okay, thank you. So we meet tomorrow or we meet only next Saturday?
Not tomorrow. Next Saturday, I'll be sending the invitation. Swapna, any question? Ganesh, any question? Venki, any comments? Suvir, how did you find this? Sham, did you like this subject? I mean, whether you can do later, but I'm just saying. Raju, any comments? How these techniques looks like? Okay, Kiran, Hema, how does it sound? The topics.
Machine learning algorithms in practice training.
Wonderful, wonderful. Giovanna, any comments?
No, Srini, this sounds very interesting. You are covering a lot of very interesting topics.
Wonderful. How much you paid in the last class?
I paid 2,000.
Okay. In case you attend this, this whole thing, the machine learning alone, will not be paying anything. In case you attend this, you'll be paying $199.
Oh, wow, that's great.
Yeah. So, because absolutely, another thing I want to tell you, whoever associate with me, they'll not be paying more in the sense, see, suppose 3 years back you took a course with me. In future, if I do anything, you'll be coming without any charges. And next is another thing, Basava. If you attend this, say this batch, next batch you want to attend for the same, you'll not be paying anything. Till you get your job, you can attend even if you skip any sessions. Generally, in each batch, we will be introducing new techniques. I think everyone knows we've done some 7 batches in the big data. Every time we introduce new technique, things will be changing, right? So definitely. So that is one thing. Generally, till you go to job, you'll have my collaboration. Even after you go to job tomorrow, you need to upgrade few things. We are doing it. You will not be paying anything, maybe a couple of hundred. Suppose usually I cap at 2,000, but these are too many things. So I have to collaborate with even Harun to give sessions and a lot of things like that. Usually whoever pays this, they will not be paying anything in the future for any of these things. Suppose Siva attended first batch, he may be attending almost free. So try to understand. So this is not a just, aspect. This is just adding a lot of value to you. Hey, if someone has an issue with money, just call me, discuss with me. Hey, if you want to pay after you get job, you can pay me your first month salary. We can work out a deal with that also, not a big deal. Not 2,000, because you need to pay at least half salary, first month salary, or 1 week salary. We'll figure it out. But money is not an issue. Money is not, you don't want to pay anything, but call me, we'll find a way. But you first to see whether this is going to add value. Yes, it adds value. There is no skill on earth as of now, at least today, more powerful than this. That's for sure. But of course, in that also, there are a lot of things. Some people studied in CMU or Stanford, they may be doing different things. Somebody may be learning this and start a company. Somebody may be using it but just for job. Somebody may be using it for break. So whatever it is. But if you talk this comfortably, people just say, wow, this is absolutely great. Okay, guys, I think it's a lot of time. Sairam, any comments?
No, sir. It's very, very interesting. I'm looking forward.
Oh, excellent, excellent. So, but we're going to do excellent. You'll be ahead of the game. And I want you to travel with me. And we support you. And we give you constant communication, because we have a teams where we even exchange ideas. Excellent. So DK, Haribabu, Narayana, Sairam, sorry, Sham, Suveer, Aruna, Giovanna, any other comment? Last 30 seconds.
So Srini,
Yeah.
Yeah. You know, my quick comment on this is when I looked at the content, it is first thing that stands out is you're covering a lot of topics, a lot of grounds. So your earlier courses were, used to cover big data, but now you are going beyond that, machine learning, deep learning, AI. So this is definitely a very good class for new job seekers, as well as, people who are trying to retool their skill sets and get into the newer or hotter areas. That's one thing. And today's session was, for me, I mean, I'm just like starting to get to know about this field, but it gave me already a good understanding of the basics, what to expect in the technique. So I definitely encourage people to take this class and retool their skill sets. Very good class.
Well, wonderful, Suveer. That's a good point you highlighted, especially people have a challenge. How can you learn these many things? This is where my experience comes into handy. I've been training people last 25 years. I trained maths for 11th, 12th people, trained a lot of people in different areas. How to optimize a training, that is my skill. So I've been doing a lot of research. How can you gain insight? See, the same course I can teach in 2 months, or I can teach 6 months. The same course I can teach 1 month, but I can tailor it, based on the need. This is called whole is bigger than sum of its parts. You may skip few details, but it doesn't matter. You need to see the whole picture, because when you are driving, you see the whole picture in your eyes. Your eyes can see, even though you don't see absolutely clear, you have a big picture. Hey, left side cars are there, everything you have a picture. You will be seeing it and going every day. So that's how we do. I optimized it because I don't want some handicap. So this is how the enterprise AI looks like. You go and talk to me, this is what I know, this much I know. Okay. That's why we didn't take hundreds of algorithms. In machine learning, we took most 80% of problems falls into these 4 prediction algorithms: clustering algorithm, classification, and this recommendation engine. If you know just the recommendation engine itself, there are companies who can hire you. But this neural network is absolutely amazing. You go and talk to PhD people, you share your knowledge. Even today, whatever you learn, I'll try to share these slides with you. They will really, really appreciate it. But anyway, guys, I think I appreciate your time. Generally, we don't go more time. Already 30 minutes crossed because of some, I think, too much this one. And so I truly appreciate everyone. Looking forward to collaborate with you. If you're not ready for this batch, don't worry. You just connect with us. We'll be working with you in the coming months. But trust me, in every field, you escape from this, but you cannot escape from this, because this is going to touch you. That's what I can promise. Great, guys.
Thank you, Srini. Thank you very much.
Okay. Thank you, Srini.
Cool. Have a good day. DK, thanks for joining. Giovanna, Babu, Mohan, Narayana, bye. Shiva.
Thank you.
Thank you. See you next Saturday.
Yes, looking forward to see you. Harish.
Thank you.
Welcome. I know I miss you. You're busy, but I'll share you the recording.
Sure, Srini.
Aruna, Kiran, we miss your. Harun, we missed your demo, but we're looking forward for your demo next week. Kiran, Kiran, please welcome. I know big data, you didn't take a leap, but this is a cool area you can take a leap, because this doesn't involve a lot of technical things.
Srini, can you hear me?
Yeah, I can hear it.
I'm wondering, what if somebody has already taken the big data class? Can they not skip the initial classes?
That's a good question. Actually,
will they still be able to catch up?
We'll be doing differently. We'll be doing sequentially. So this big data will be a small part. You will see. We don't do whole thing 5 weeks and go like this. Just like we even start in first week itself, we start machine learning. As you do machine learning, you need to get data. Then we go to Hadoop and get the data. So your other skills only a little bit auxiliary skills. If we do a 5 weeks or 4 weeks of big data, first 4 weeks you will get bored. It won't go like that. I have designed it in a very intelligently. You get it?
Mm-hmm.
Yeah, see here today we discussed, right? Did we discuss anything much on big data?
No, it's just only basics.
Exactly. So even that is not much needed, because you start with the need. You start with how you build a recommendation algorithm. Oh, recommendation algorithm need to Spark libraries. Okay, import these libraries. Okay, you may be knowing how to import it. Okay, so then, and also moreover, you'll be learning a lot of auxiliary functions. Scala, if you will be earlier only you'll be reading and applying data frames. Here, to do the data cleanup, you might have to apply some custom functions. So those will come into handy for you. Kiran, does that help you?
Yes.
Yeah, it's not sequence actually.
So
Yeah.
this course would not replace the other big data training that you've been doing. That covers that more deeper. Is it what you're saying?
I don't say it's a deeper. See, what we discuss because that is course that is optimized for that. Okay, there will be show you I may be showing a lot of Scala techniques, a lot of Scala collections. All in an hour we'll be making sure it goes deep into your brain. All those things. So whereas here, I give you some points. Some maybe you will be working in the weekdays, because we have to optimize these machine learning and deep learning, right? So that way I can say you'll be learning these techniques and how big data supports this. Like that you will be learning, because you will be planning to go to this job. That is the whole idea. If you are just want to go to this job, yeah, then we will help you side. Hey, you can reach Harun for additional understanding, all those things. But generally, I encourage you to try for a job at least as a machine learning, large-scale machine learning engineer. I don't encourage you to apply for big data developer job. I want you to apply for large-scale machine learning engineer job. So at least these two. So that way, so it is not a replacement. I can say it is auxiliary. Okay. Yeah, some people they can leave. If anyone has any questions, any other questions?
Not really, not for now. Thank you.
Yeah, whoever doesn't have question, request you to leave. I'll stay another 5 minutes. Who can talk to me? Especially India, it is late. Razu. Yeah, okay, I think it's late time for you. Thanks for staying. Any other questions? Kiran? Ganesh? Siva?
No, Srini, we are good. It's pretty interesting. Thank you.
Okay. Wonderful, guys. Then I'm stopping this. Okay, thanks everyone. Thanks, Giovanna. Thanks everyone.